Still trying to get these streams connected and working. Right now I'm trying to build a reader interface on my writer stream, which the idea is that I'm gonna have my interface just so I can have more control, I guess. Just to get it through, like how this works. Now, it could turn out that we don't need this construct and we could just use a reader, like just the reader. But I'm gonna try and do this anyway. So the reader vtable has 4 things: stream, discard, readvec, rebase that you need to implement. And the reader is, or the stream is basically, you get a reader and the reader and a writer. The reader is self. The writer, I guess, is where you put things into the reader buffer. And then there's a limit as well. Well, I guess the writer also could be forwarded to whatever is trying to read from the reader, I guess. And then, yeah, the limit here. So the way it's gonna work is that we get our stream and we call next inner on that, which will get us some kind of string, and yeah, we catch on it as well, and or the read could fail for some reason. If it's null, that means we don't have anything, so we return 0. But if we had something, then we should now see what it is. So either we have a completed event, which means that in the reader interface you have to return an error, that is the stream or end of stream error. Otherwise we will get the next item out. And the thing is, now I realize that this structure that I have, like stream, the type here, stream of string, like this doesn't really work. We need this to be kind of like I don't know. Yeah, this whole setup doesn't work very well, I would say, because it's like this string can be arbitrarily long, and you know, you could get, like, what do you do with the rest if they only want like 256 bytes or something, and we get a megabyte or a kilobyte or whatever? What do we do with the rest of the thing? So I think I need to change this either to not be a string and just be a U8 instead, and then make it so that this is just basically a reader wrapper. Hello SKF, welcome back. What's up? Yeah, I think we have to kind of do this. And I'm good, a little bit feeling something coming on, but we'll see if it stabilizes. It's those times this year around. Many people are sick right now around here, so yeah. You know, a cold or whatever. It's nothing serious, you know. All right, so let's say we got like the next one. But the thing is, like, this is gonna be so overhead, a lot of overhead here. Because next only grabs like one item. So I think that what I want to do is I want to basically incorporate the limit into the interface. Because that makes a lot of sense. Like you say, okay, well, how many items? Because then you can say, okay, I just want one item, or I want, you know, how many items, well, however many items I want. Which means that next you could kind of say, you could provide a limit. Yeah, let's just do that. So that's a reader limit. So now basically you can say, hey, I want one item, I want nothing, or unlimited, or yeah, or limited. Interesting. This is like, I've never seen this actually. So this, I guess this means it can be anything. Interesting. And then it's like a value. Oh, thank you. Yeah, we'll see how long I will stream today. Wait, limit is not called, not called. Oh, it's just this. Maybe. Yeah, it's the same thing. Unused switcher. Yeah. So we'll forward that. And then this would be like a stream event of T. However, now T is should always be a list. Oops. All of these need a limit. We also need to forward it. Hey, Power Checker, what's up? How's it going with your project? I think what you made was it some kind of language, or what was it? Unused function. Yeah. Exactly. So yeah, we have a buffer of T's. Yeah. So this should be pretty simple. So basically, yeah, we're checking for completed. We are honestly, we could just make a reader of this buffer, to be honest. It's just that the buffer needs to be a pointer. When you initialize, we don't have the pointer yet, so. Yeah. Okay, well, I think I tried to make these into reader, like the stream into readers before, but the problem is that we can allow any type here, while the reader only allows bytes. And that's the issue. So I only added it to like byte streams. So, but okay, let's see if this is Okay, so either we are already at the end, or we are at the end. So either we already was completed, or we are at the end, in which case we set our state to be completed. And then and return completed as well. And then we add index plus 1. Now this is where we need a little bit more logic, but yeah. Stagnating, okay. Yeah, sometimes can be like that, like well, let's just try and do this here. So this would be like index plus 1. I mean, if someone puts a limit, how? Okay, so if we go to, let's go to the reader, let's go to the fixed reader. And ending stream. Oh, I see. So it just has the buffer. Okay, so it's using kind of the reader interface to just read from. Okay. So then we should look at the reader function. I don't know. Read. What would it be? Read slice. I'm gonna look at read slice short. Right? So this is kind of the same thing. Oh, except it doesn't take a limit. Oh. Limit, no. Alloc remaining, append remaining, okay. With a limit. Allocating. Init own slice. Okay, so we supply a list, transfers all bytes to current position and stream up to the limit, appending them to list. Okay, but that's cheating. Like that's. Okay, you know what? Let's just figure it out. I thought I was gonna get like some nice example there, but okay. So what options do we have? We have either we have nothing. That's a trivial example. We just return null. If you want nothing, then we'll give you nothing. If we get unlimited, that is another. So basically, as much as exists right now, I guess. Well, this would just return the rest of the buffer, actually. So it's not gonna be the end of the stream because we already checked that up here. So we should have at least one item. So basically this is gonna be like self. So like next buffer. That's gonna be that. And this is actually always now gonna be a slice. Should we have a case for a one item? Just in case. It just makes things easier to process. Like if you expect one item to come out, I don't know. Okay, well, let's do that. So that's that. And I guess it's up to the caller to kind of duplicate this value or something. Okay. Yeah, we do that. And then we have to set index. Well, we don't need to defer that actually. We already have it. So this is null at this point. So we'll just return the rest and it's null. And I guess switch, like this could be something else now. We have to have like an else n. Now, do we get the number out here, or how does this work? We get limit. So do we have to turn it into like an int? Requested is int from enum, which will give us a usize. Okay. And then, right. So now we could just we can just give it up to buffer length. So basically, let's do return next self buffer index to index plus requested. And we'll defer, or we don't even need to defer. We can just set index is equal plus equals to requested. However, this could be out of bounds, so we have to say end is gonna be max buffer length or index plus requested, and that's the end. And I guess index is going to be set to the end at this point. And the next time you will get a completed event. Hello, I'm Jay. What is this used for? This particular function that I'm doing here? I'm trying out to build like a stream interface. Hardware system? Or do you mean the language itself? the language that I'm building. Oops. I mean, the idea is basically it's just gonna be for my personal use to build, you know, bash-like scripts that I'm using in my other work, like, so just, you know, quick and dirty scripts that achieve some kind of task, and it's just to make it easier for me to actually write the scripts, so that I don't have to deal with the bash syntax. Basically, it's gonna be for scripts only. There's not gonna be like a shell, or there's not gonna be a compiled language or anything like that. It's just gonna be an interpreted script language, and the idea is just to have script files that you can run with the executable, with the runic interpreter executable. That's the idea, but then it's also mainly also for learning how to make languages as well. So yeah, you could say that it could be used in a command line. You know, I mean, when I'm developing in a terminal-based environment only. Well, except for Windows outside. Like if I like this, I'm running this in WSL, and my normal operating system is the Windows, but this development environment is in Linux, in WSL. Hope that answered your question there. Okay, so unlimited, we just take rest, index null. Otherwise, we check how much is requested. We will say... Actually, I need to go and read about the stream. No, not this one. No, okay, no, that's fine. This is my own interface, so I can decide here. So basically, we're just saying that if someone requests more than is available, we just return what's available, and next time you request more, there's going to be a completed event. Okay. Yeah, I mean, that should be it here, and we don't really do this anymore. There we go. So now we've incorporated limits here. And we have to do the same for the other ones. Now, this one is a bit special, I guess. Like, we don't even need this, to be honest. Like, it's the transformer. I guess I used it because so I didn't have to. Well, actually, you know what? We can just use it. I mean, yeah, we don't have to have our own. It doesn't have to be its own stream. We can just use a buffer stream. Let's just remove this whole thing. It's just gonna be, or I renamed it to fixed stream. So this is just gonna be a fixed stream, and we just put the item in this buffer here. But the buffer, it's kind of interesting because the buffer is it's just put in there. It's not like duped or anything. So the lifetime of the buffer needs to be somewhere. Man, maybe we should just dupe it or something. I don't know. Mm. Maybe we can make it into a ref. Or we just dupe it. And initialize, we will initialize this as well. All right, sure. So init will need an allocator. No, wait, this was not the correct one. It's init fixed. There we go. Okay. Where are we now? So you have limit now. This thing is like it wraps an IO reader into this. Now we're not really using this right now, so I think I'll just do this for this right now. The idea is we could use this for the pipe streams from the file descriptors, like standard in, standard out, standard in, standard out, standard out. But yeah, I mean, yeah, actually, you know what, let's try and incorporate this actually. Also, I think, yeah, now we can actually change the type here. So we're gonna change this to this. Okay. So now they're not gonna be strings anymore. It's just gonna be U8s because streams now can return a string or a list of things. And we have the limit. Which we pass on through. Okay. Now I did this here. I'm not sure if we even need to do this right now. I'm gonna have to make sure here. We don't have a buffer or anything here. The only thing we have is the reader. So really when you do next inner, what we're trying to do is we're trying to like read 512 bytes. That's just an arbitrary number that I just put in there. So read in the next 512 bytes. We put them in this array and we read however much we can. But now we have a limit, so now we can do source, and then what would it be? Like, if what takes a limit here? Read. Or take. I'm trying to look for those things that take a limit. Stream delimiter limit. But that needs a writer. Although I guess we could have... No, we can't have a... Well, I guess we could have a writer actually. We could make a writer and then just stream it in there. Yeah, let's just make an allocating writer. So this would be allocating init. We need the allocator. And then you will be the allocating. And then we'll initialize this if something goes wrong, I guess. And then we'll do source stream. And we're gonna use the allocating writer as the writer. And we're just gonna pass the limit through. And now we basically don't need to do anything of this. However, this could be an error. For example, it could be end of stream. So we're gonna switch on this error and we're gonna catch reader stream error end of stream. If it's that, then we are gonna return. Then we didn't get any data or anything. We're just gonna return. I think that's how it works. Like if we go, we're just gonna return completed here. Wait, where's the? It's on the V table, I think. Yeah. All right, so this is the stream function. This is the interface stream function, which has a reader and it takes a writer and a limit. So it basically tries to push forward things to the writer, and I think this kind of bypasses the buffer of the reader, if I'm not mistaken. Writes bytes from the internal track logical position to W. Okay, I'm not sure what they mean by this. I think maybe they mean like implementation wise, like or the implementation of the interface has this. I'm not sure if they mean like the buffer of the reader or returns number of bytes written, which will be at minimum 0. Yeah, and at most limit, the number returned including 0 does not indicate end of stream. Yes, the reader's internal logical seek position moves forward in accordance with the number of bytes returned from this function. Implementations are encouraged to utilize mandatory minimum buffer sizes combined with short reads, returning a value less than the limit in order to minimize complexity. Okay, so it's kind of maxing out, like even if you request unlimited, you might not get. Is that what they're saying? Right. Like even if you request unlimited, you might not get like everything that is there. Although this function is usually called when buffer is empty, it is also called, right, so when buffer is empty, because all readers have like an innate buffer. All readers have a buffer because it's part of the interface. And I guess it kind of uses the buffer as the first thing it's, you know, accessing to. It tries to empty the buffer first before it starts to call this function. So if it had something in the buffer and you request, I guess more what's in the buffer, it consumes it and then it starts to read from the stream. It is also called when it needs to be filled more due to the API user requesting contiguous memory. In any case, existing buffer data should be ignored. The new data written to, yeah. Because this stream should not care about the buffer. It should just write directly from the source, as it says here. In addition to or instead of writing W, the implementation may choose to store data in buffer. Modifying seek can end accordingly. Ah, I see. Implementations are encouraged to take advantage of this if it simplifies the logic. I see. Okay, so I forgot the question that I had. So I guess you could use stream if you have like a buffer of 0 length. You can use stream willy-nilly, but as soon as you have like a buffer with any length, that's gonna be more tricky. Like, what would be the equivalent? Like, because I would like to do this, but with buffer behavior as well taken into account. So what would that be? And there's so many functions here. Append remaining. Transfers all bytes into a list, right? Hello, Peter Bolso. What's going on? Welcome. Because this seems to be such a perfect function, but it doesn't take buffer into account. So actually, it does take buffer into account. What the hell? Also, oh yeah, but this is like the generic one, right? Isn't this like a generic? Wait, what does it take from? It only takes from the buffer. I see, so you can maybe use the original stream function first. Perhaps. No, this one takes the vtable as well. Okay, so this is the function you call as like an API user. And then this would call the inner stream function, which is like, okay. Right, so this is actually correct. Okay. I see. So if we are at the end of stream, we return completed. Otherwise, there's some other kind of error. I would just return that, because this error, we encapsulate all of these errors in our own error type, except for end of stream, I guess. So and this could be like both write failed and read failed. Well, okay, it's only 3 errors anyway, so I'm just gonna say read failed. It's gonna be read failed, and then write failed. And I added the flash modified F and T. So, and then you can't repeat. Like, it messes up the repeat of that. Like, if you do C, T, F, and then we go over here, and now I do repeat, it's totally messed up. I'm gonna disable that. I don't even like that function. Like, what it gives you is basically, now you F, W, and then you can press F again to get to the next W or back. But I mean, I don't really use that. I would rather, instead, if I want to go to the first thing, I could use F quickly. But if I see something over anywhere else, I could just use flash to get there, for example. If I think about it. Okay, anyway, so now we have a size, so this would be bytes red. Do we even need to know that? Do we even care about that? I don't think so. Actually, we do. Because if bytes red is 0, we return null. But now, I guess we could actually remove that whole thing. Actually, the stream event, we can actually remove this nullable now, because this is a list, so we can treat an empty list as a null now instead. So we should actually remove that. I just realized. So then it simplifies this as well. So this would basically, this would just be alloc writer to own slice. And you don't need the allocator now. There we go. And you, we don't care about you. Okay. So, yeah, let's do that. That makes sense. So if we have nothing, we should still return. So nothing, if I'm correct here, nothing also is 0. So we could use it as a value with int from enum. So even if we don't have the nothing case here, it will get caught here. So unlimited is the only one that we need to have a special thing for. Otherwise, we just use n. Now, how does that... Oh, I see. So the number of unlimited is like the max int. Okay, that makes sense. Yeah, so that's... I mean, okay. I guess we can do... I guess we don't need a special case for unlimited either. We just take... You know, we just take n is int from enum limit. And we just use this generic algorithm instead. We don't need to... Yeah, or this is the requested, yeah. We don't need to like switch or anything. We just grab out this as a number. Is there even a thing here? Min int, non-zero, slice. Oh, there's even like things here. What the hell? Well, I mean, we already have the algorithm here, but we could say limit slice and do self buffer, except we need to start at index. Okay, so result is gonna be limit slice. I'm just trying to learn more like how we can do this. So that's starting at the index. And then we can return that. Now, what would self-index be? It's basically gonna be plus equals result length, right? Because presumably that's gonna be how much is requested. If it's 0, it's like request nothing. If it's 1, this length is gonna be 1, right? That should just be what we need to do there. And then we can just simply return that. We can even do... No, we can't. We need the result slice. But that, yeah, cool. So you can use limits like that. Okay. Now, where were we? We've done... So did we do fixed stream now? Yes. And this guy is next. Right, that one we did as well. I think this should be So we basically have an alloc rider. We just stream into that with the limit. This is all built in. And we just reroute the errors a little bit and we return this here. Okay. Whoops. Okay, so we should be done there. Oh yeah, the only thing over here, the fixed thing, since we're duplicating the buffer, we also need to deinitialize here. So let's get the allocator. Now, if you can't get the allocator, I guess we're screwed. But we get it, and then we do if we have it, we will free let's also get the parent. We will free parent.buffer. Okay, now we're down here. Let's change this limit. And it's probably gonna turn out that we could just use like the reader interface instead of doing all this. But the one thing that these streams give us is like typed streams. Readers and writers only work with bytes. So that's kind of, yeah. And also I'm learning, you know, about the interfaces, how to build them properly, and the reader and writer interfaces. So it's all good. Okay, now this is kind of the same thing here as the fixed. Well, actually it's not. Well, okay. So this would be, well, actually it is kind of exactly the same, to be honest. I'm just going to probably nuke all this. And then we have this reader, which is, no, that's the interface. What is the source of this actually? We need a source that's a reader, I guess. You are a writer. Reader writer stream. What was the ID here? I guess I'm gonna do this, and I'll come back to this because I'm not sure if we even need that. And then we have this byte transformer stream. I'm not gonna touch this right now. We have the mapped stream. You need to change a little bit. Next, we're gonna have limit. And you are not optional. All right, so we're calling next on the source with the limit. And it can't be null, so this doesn't work. So I guess we can actually, we'll just switch on this directly here now. And if we're completed, we're completed. If we have next, we have the next, and then we call map on that. However, now, wait, why is this optional? Oh, it's because of the interface. I see. The V table is there, yes. And you are not optional. And you have a limit. Okay. There we go. Now this is not optional. So we get a list of things in. We map. But now we actually need to call. We need to like create a new list as well. So we need to see this list. We don't need to worry about. That's owned by the stream source. But we need to create a new list actually, which kind of goes against it a little bit actually. It goes against the interface. Yeah. Wait. Well, we could just say that the reader is supposed to take care of the results, I guess, as well. How about this? You're just using the buffer, so that we have to dupe it in that case. Actually. Because all of them need to be the same, because the consumer needs to know how to handle the results. I guess maybe actually the stream event could have a deinitialize function maybe. And then that could be depending on... Yeah. Okay, so this could be like a deinitialize one thing... like depending on the implementation, maybe you can have different initialize functions, because you could just be a pointer to a function that takes the stream event, or well, yeah, the stream event t, which is gonna be this, well, and then returns void. Man. Well, okay, let's actually finish this, the mapped stream here first. Yeah, let's finish this one. So let's do result is gonna be, so we're gonna get the allocator, and then we're gonna allocate a bunch of t's or outs, which is gonna be the same as n.length. And then we're gonna loop through all of these, and we're gonna call the map function on the result. Let's see, well, okay, so we need n as well, so this is gonna be out and this is gonna be in. So we're mapping on the in, and we get some, and we set out to that. And if something goes wrong in the map function, we're gonna catch this error, set that there, and we'll be done. And next is gonna be the result. Also, we have to also now we need this as a thing, so next, source next. So we initialize that. And here deinit needs to be set now. Oh shit. This is not a, okay, this is not a struct, right? Ah. Well, I guess we could put this on next then. We could have a struct here with the deinitialize function probably, yeah. Sure. And you are the payload. Wait. What's the issue? Okay, well, anyway, now we have to say payload here, and payload is results, deinit is deinit payload, which we will I guess we also need the allocator in that case. Do we need to supply the allocator then? I guess it's fine. The allocator is just a couple of pointers. I feel like I'm doing this way too complicated than it has to be, but I just want to solve the issue, you know? Also, why do you not have it? Oh, I see. We could create a convenience function for you actually. So basically here you could provide a deinit function, self is this, and then we will switch self if we are a payload. Then no, next I mean. Then we do next deinit. No, not next deinit. We do deinit self. Or yeah, we do this next dot deinit to get the function, and then we call with self there. Yeah. Otherwise, we don't need to do anything. Well, if we complete it, we don't need to do anything because we don't have any data. There we go. So now we should have this deinit function. And hello Breeder98, how long have you been programming in Zig? About a year. I started last year in November sometime, so a little bit over a year. Are you interested in Zig as well? Okay, so now you would be, well, if we have the allocator, we don't really need a special init function. Yeah, because this can't really have any closures or anything like that. It's kind of interesting. I've been thinking about that sometime. Like, we should be able to create like a closure construct, like a function. It's kind of like a function, but it's wrapped in a struct and it has a closure. So it could, but it could be, it has to be kind of like an interface, I think. Because the closure could be potentially be anything. And the function also has to know what the context is and how to use it. So it's basically like a function that you can call with some extra data attached. Well, I'm not gonna do that right now, but it's I've been thinking about that for a while, and I mean, it should be possible to build something that is generic, so you don't have to build the closures over and over. I guess they are kind of very specialized, but I mean, for example, for this one, it's like, yeah, we're gonna need, you know, it's only here, but this function needs more information, so we need like some kind of the initializer or something that has the allocator that we need, and then the initialize function. But the thing is, like, we don't always want the allocator, we don't always have it or want it, so it's like, well, I guess it could be, no, yeah, because otherwise we need to store it here. And then we don't even need this. We don't even need to have a special thing here. We could just use the allocator to deallocate the payload. Okay, sure. Let's just do that, and we'll not worry about optimization right now. We'll try and fix it later. So basically, well, what we need is the allocator. Let's make this a little bit more convenient here. So let's make a function called like init next, and we need the allocator and the payload, and we can even dupe it in here, I guess. Well, no, let's not do, well, god damn it. This returns this, so this would be a next. Yeah, let's just dupe it here, because that makes sure that this type is actually, or this allocator is the one that actually did this thing. We'll dupe the payload, and now I actually have to add a allocator error here. I like to now explicitly put the errors, because it's easier to kind of see. If you need to know the error, it's easier to see what it is. No, what am I doing? Allocator is equal to allocator. There we go. Want to learn kind of suck at programming? Okay, well, practice makes perfect, as I say. Just keep at it and it'll be good. Did you work with any low-level language before Zig? Yes. Well, I started out when I started out, I did some C++. But then I went over to higher languages, and I've been kind of going back and forth a little bit, but I've been mostly with higher level languages throughout my career, I would say. So Zig is like one of the first, in recent times, low level languages that I've been working with. So I knew about, you know, pointers and all that, and but never really, you know, gotten into doing something more advanced, I guess, with that kind of stuff. Okay, let's do init next. Well, actually, we can do this init next. Allocator and result. Well. Right. However, we could just make the result right here, actually. No, we would need to dupe it anyway. Okay, well, let's just do allocator free result. I know it's very unoptimized, but whatever. Okay, where are we now? Right, there's no single stream. We're gonna use a fixed stream instead. And init. I'm just gonna supply this because it's gonna get duped. So, yeah. That's fine. Now, where are we? We have a bunch of loose ends here. What is this? This is the main stream thing. And what's your issue here? Right, take all. So yeah, this one, as it says here, it's blocking until, so basically we're trying to loop and get all the things from the stream until it's done. And now this would be like unlimited here. Is that all we need to do here? Right, so we actually don't need to do an if anymore. We could do a switch instead directly, and then we can do this because null doesn't mean anything. There we go. And then you would be payload. And also we need to deinitialize as well. So we need to do like source next or whatever. I guess we'll tack this on here. And I will switch on this. And we also need to defer deinitialize. There we go. All right. Append slice, fine. Okay. Where are we now? Fixed stream. Oh yeah. Wait, or what? Slice. Oh, you need a limit. No, the limit is here. And then the slice is there. Oh, because you're a const. Oh, the limit only works for bytes. Wow, okay. It only works for like byte slices. What the hell? Okay, well, let's do like min int, and then it's gonna be buffer index, no, length minus index, I think, yeah. So whatever is less this limit or this is gonna be the and. Yeah, and then that shouldn't change. But now we can just set it to end instead. All right. Payload is result. Wait, so the buffer is const. I guess it doesn't really need to be const. What are you now? Mapped stream, right. Okay. So how much did we do here? We got the source. We initialize. We make the results. You are now payload length. And okay, so apparently this could return null for some reason. I don't remember why I did it like that. Like that should be that could just be part of the type out type if it's supposed to be optional. I think we just omit that. Like, I'm not sure why. I think it might be. No, I don't know actually. Okay. What's going on here? Map function. Okay, and now that's wrong because of one of the usages of this. Okay, it's because you return like optional t. So, but then we just change this. No, this should just take the whatever result is in there though. Oh, we remove the optional. Okay, well, don't do that. There we go. Okay, there we go. It's kind of interesting, like the comp time stuff and everything. It's kind of like you can do. Yeah, it feels like the comp time stuff feels very functional sometimes. While you're working with, it's like working with functional and low level at the same time. And and also it's kind of what I like about Zig also is like it feels like you're building. Like some people don't like it, but I really like it. Like you're building your own, like these constructs, like closures and interfaces, vtables. You're building it up yourself, which as I said, like most or some people don't. Some people want to have it on their silver platter. I don't know. I like to build it. It feels like you have. I like what I like is the feeling of having like total control and nothing can stop you. Basically, you can just dream up whatever you want to build and just build it. Expected type. Okay, so you want a pointer to something something. So you are a pointer stream limit stream error stream event. You are optional. Okay. Oh yeah, this is the failed stream. Right. So we haven't done this one yet. So let's add a limit here, but we don't care about the limit. So it's just gonna be this. And we will, yeah, we're unwrapping that. Is that it? Okay. Well, we got some stuff here. Source. Is a stream, yes. And what is your issue? Inverter is not relevant. Okay, optional stream. This gives us a stream, right? Why is it optional? Because this returns optional. But what's the issue really? Expected type, it's not optional, I don't think. String, okay, so this, and then we found this. I see. Actually, also the stream, now we don't deal with these anymore. We actually deal with these. So I'm gonna change that there. One second, I'll be right back. All right. Yes. Okay. Let's see. You. Gonna be you. And from value does the transform, I guess. Okay. Right. You forward string stream. Yeah, I think we're gonna change this a little bit because, or yeah, I'm not sure actually. Because these pipes, they're basically like the standard out is basically, I mean, it's just a rider. And but then there's like this behavior down here, like if we need to flush or not, like if we need to forget about the written values or not. Because if we do want to keep it here, we're just writing and then flushing directly, so then it just disappears. But if it's written out to, you know, the standard out or some file or something, then we do need to flush. I guess maybe we could flush somewhere else, but yeah, this streaming check is like, it doesn't really make sense right now. It should be like, should flush immediately or something, I don't know. But this whole thing's probably gonna change. And also we will do, I guess, unlimited. And we'll catch some error, and we should always get something here. So actually it's like whatever's in here, we actually need to, well, we need to do like a while like this. While true, we get the stream next, and then we look at that and we forward that to something else. Now if we know that we're dealing with U8, we could also like create just a streaming function here for convenience. Stream to IO or something. I don't think we can call it stream because there's too many things called stream in here. Or maybe we can actually. Stream. Can we call this stream? Yeah. Alright. Cool. Because that's the same as the readers. Stream into the writer. And we have a limit. And we basically do what we do here. No, actually, we could just say, also first we want to check if t is equal to u8. So if it's not u8, then we have a compiler error. Or if it's not, I mean, if it's not u8, yeah. it's a compiler, and we can say stream only available on stream direct actual stream. All right. Now we can also now basically produce a reader maybe also. Like if it's a stream U8, we could just produce a reader probably. See, that's what I tried to do up here, the reader interface. Where was that? This part here. We could potentially put a reader on every stream. However, it's only going to be available basically if it's a byte stream. But basically this is what we would have to do. I guess we could just copy this actually. But we call next with limit. Okay. However, we will just say stream error, and that will do a try here because we're working within the streaming thing, so we don't really need to do anything else there. Okay, and that's our next thing. And then we don't really need to switch on it either. Or wait, no, we do. But we can do, if we're completed, we don't need to do anything. Or, well, we could return, I guess we could return the actual event here that we got, so that you can inspect it, because it's only going to be one event. So I guess this would be stream event of T. And we'll return that. But before we do that, we will also actually, you have to deinitialize it. If we return it, then the owner actually needs to deinitialize it. So, or the caller, I mean. Caller needs to deinit returns value. Hello, Penguin. Alright. So, and then we have the next, so now we have the payload. So now we can just put that into the writer. So now the writer, we're just gonna write all, actually, no, I think we can do that. Because the only thing this can do is write failed, yeah. Which we also have, so that's fine. And then we do the payload. And yeah, I think that's it. Okay. right. Now here then what we do is like while true, we will get stream next. It's gonna be stream. Let's do like event is stream into rider with unlimited, and if there's something wrong, we will log that and return. Should we return the error actually? Yeah, we'll just return the error actually. And then we also deinitialize that. And we don't need to do this. We still have the flush thing. There we go. Right, we don't have this. Okay, so now we're back here again. So this is like the pipe operator. This should really be its own function, to be honest. But yeah, this is the pipe binary operator. I could probably make a macro later to turn these into functions, but okay, not right now. So the pipe operator is very interesting here. So first we are trying to, so this, all this up here is for the left hand side of the pipe. So what's happening is that, yeah, there's a lot of things happening here actually. But we make this rider, which is supposed to capture whatever is coming from standard out when we evaluate this left expression. And then the idea is we turn it into a stream. So, and then the right hand side, and so the left will be a stream, and then the right hand side we evaluate as well, which is just a function ref. Hello NG Tentai, welcome back. How's it going? So the right hand side is a function, and the left hand side is like a stream where we capture whatever's coming out from there, which could be, it could be a, you know, executable like echo whatever. It could be just a string that is turned into a stream, or anything that is like could be turned into a stream is taken from there. Now we need to do some coercion as well, but yeah, left has to be a stream otherwise, or be able to be coerced into a stream, or this will be kind of like some kind of well, yeah, unsupported binary expression. Although this could be more specific here, because left has to be a stream, right has to be a function. If it's anything else, it's going to be an unsupported binary expression. We could also log out, hey, in this pipe, the left-hand side is something else, right-hand side is something else. But yeah. Anyway, so let's say we have this one left one as a stream, and then I'm trying to make up this function here, init with stream. Now, standard in is a reader, and standard outs, those are writers, so that you can write to them, and standard in is a reader, so you can read from it. And we don't really have this init with stream function. And this one is the stream, actual stream here. Now the streams has to be stream of values, because I think so anyway, because they kind of have to be generic. I think. Well, otherwise we would have to kind of encode the type of the stream in the stream itself, maybe. Perhaps. I mean, we could just add, I guess we could just add the type expression of the value. And then have some kind of function that turns it into a zig type. And we can use that to know the type of the stream. Because this is like very generic here. It can be stream of anything. Each item you get out could be anything, basically. You can have a bunch of values that can be anything themselves. But really, we are working with bytes here. So this is going to get turned into a byte stream, or like, yeah, a reader. And that is why I wanted to have the IO reader byte stream, which I guess we have now. So basically, this takes a reader as the source and turns it into a stream that you can have. Wait, but this is like the other way around. Now, why is it so hard to wrap your head around? Right. This is writing. So this expression is going to write into this writer. And it's also meant to be... Yeah, okay. Now it's going back to me. Like yesterday, we were talking about the child processes and everything. And now we store them in a map so that they can be spawned. And then later, at the end of the program, we wait on all processes that has not yet been completed. So we wait for them. But here, this could potentially spawn up a process, which will then have to keep this around as well. So that's why we're putting it into an RC here. So we keep it around until it's not needed anymore. When we also have to kind of check when the process, or when this thing does not need a writer anymore, it actually has to, we have to kind of delete this ref then. But how would we know that? Like we would have to connect that somehow. Right now it's just taking, we're just saying that, hey, you should write to this writer, but we don't really know which process is doing that. It could be anything that spawned from here could write to this writer, but we need to know when we should remove it as well. Yeah. Or we could, I guess we could just put it in the, we could also just put it in the arena, I guess. But you know, that doesn't really clean it up, like if you have a long running thing. Yeah. I mean, yeah. Because the issue is, like, when we evaluate this expression, it should really become like a stream at this point. The thing is, maybe we should change these to be streams or something. These maybe need more information here. Or another way to think about it is that we just need to keep this alive during this scope, because at the end of this scope we should have, since the evaluation tree, since the binary tree for the pipes, the topmost tree should always include all the other pipes. So we're setting up these riders. Yeah. Okay. So on the right hand side you would have... Wait, no, that's not the case though. Yes, that is the case. Sorry. Yeah. We need to wait for the right hand side to be done. Then we can... Yeah, okay. Well, we set up the left hand side first, and then we need to wait for the right hand side. Okay. Unless it's a background process. But we don't really have support for that right now. So I'm just gonna leave that where it is right now. Okay. I just want to solve this issue right now because I've been rebuilding this the pipelines for a while now. I really want to make it work. Hello, Kufti. Welcome back. What's up? Okay, so right, so we have this rider. And the right hand side, yeah, this is correct. We just need to do this part now. So we need to create... Well, okay, there's two things. We need to coerce this into a stream if it's not already a stream. And then we need to... Well, actually... The left hand side... Like, what happens if this is actually an executable? What do we return? I think we return void at the end. Yeah. This isn't really correct though. I'm not sure. No, it's probably correct actually, because a stream implies we... No, we have to... No, yeah, this is correct. We have to actually capture it with the context and turn that into a stream. So we can't actually use the left-hand side expression. We can actually check if it's it has to be like a void. It could also be a stream, I guess. But if it's a stream... No, I guess it could be a stream, yeah. But wait, then we can get capturing and stream. How does that work? Alright. Alright, Kufti. Is that how you say name, by the way? Sorry if I butchered it. Toady. That's someone else. That's another developer. Or not Toady, but Toady1. From Dwarf Fortress. You don't know? Okay. Is it your given name or? Oh, okay. Yeah, okay. Yeah, hope it goes well. Bye-bye. Okay. Oh, man. Gathering the thoughts. Yeah, what if this is just a string? Because this won't actually... Maybe we should execute the expression actually, because that will turn it into a stream that forwards it. like that. Now there's a difference between evaluating an expression and executing it. So we're executing the expression. That means we try to make it into a stream and forward it before we return the value. And yeah, if it's not possible though, well, it's gonna be an invalid source. Actually, okay, well, that's why we don't return the error here. I guess we could catch though. We could catch and switch and check if it's invalid source, or, well, this would be like stream error. Then we don't really care, we just move on. Otherwise, if it's something else, we should return it. Oh. What the hell? Can we do this? No, that's shadowing. Wait, unused capture, what? Does that work? See, this, I think this stems from that we're capturing the error here. I wonder why that happens. Like, is it because the errors are not like fully inferred yet? But we have this here though. Because you can put this over here, and I think now it's gonna work. Yeah, now we don't get the error. But that's not what I want. I want it to be up here. What if we put it there? Is it still an error? Yeah. Man, this is like one of the compiler bugs that I don't really like. Because I just want to forward this error here. How can I do that? How can we forward the error? Because I know that we have stream error as part of this error here. So it's not a case of... Wait. Yeah, and this is just error. So we're just basically forwarding the same type of error that we should have. I wonder if you can do something here to make it not be a problem. Actually, I'll just make a quick search here on Zig. Oops. How's it going with 0.16? Well, still making headway there. Zig Erdifer capture issue. Man, there's a lot of issues on GitHub. Okay, so I think this might have been... No? Well, that's on 0.14. Okay, well, anyway, whatever. How could you solve this here? I just want to return this error. Like, you can try. There's like, if we try, there's no error here. Like, you can try and it will just forward the error out. As soon as you want to capture it and return something else, now all of a sudden there's an issue. Coffee or tea? Coffee. Are you asking my preferences or what I'm drinking right now? Both are the same answer. Can you do this? Because that's not. Oh. Can you do this? No, that's not comp time, right? God. Can you cast it? What the hell? Expected error, union type found, any error. Look at all these. Look at all these @s functions here, built-in functions, whatever they're called. What the hell? So I'm trying to say that, okay, well, this is supposed to be the function name from this type. Okay, that's the function here. Get the type info, check the return type, or yeah, that's the type that we're trying to cast into. It's still errors here. Wait, expected type found function. Oh, wait. Field info. There we go. Oh, shoot. Well, okay, let's just use the dot execute expression. Actually, we could do like string to enum. And the enum is field enum of this. No, it's not field enum though. It's a declaration. let's try doing this. Actually, now this is not, this isn't error or v, this is error or void. No, still same issue, okay. Well, we're not really getting around this. Maybe I should just... We don't actually... Okay, this is kind of stupid as well. Like, we don't really need this Erdifer here because the reason why I have this here is that we can track all the way from whatever call stack we had from within. Like, whenever there's an error in any of these functions, it's gonna bubble up, and we're gonna log on each call stack like along the way. So each function that has been called is gonna log out the error. So then we're seeing like the trace of the thing. So that's why I have this Erdifer. But really, this is always gonna call the invalid expression. So if invalid expression errors, we know that we have errored here as well, because there's a try here. So we don't actually really need that. And now, you know, with this expression gone, the bug is also not happening. So okay, I was just seeing if I could solve it, if I could like not fix the bug, but because I'm not working in the compiler, but yeah, circumvent it, have a workaround basically. Yeah, all right, anyway, did not succeed with that. Great, so now we're back here. Okay, but now we, instead of doing evaluate, we actually do execute expression, which will forward this to a stream. And now the only thing that should be from left should be a void at this point. That's the only thing we should be able to get from left now. Also, you are optional, apparently. Are you actually an optional? I don't think you are. Like, we don't have return null anywhere, so you're not an optional. Okay. And right, so now, yeah, so we have the initialize on both of them. The only reasonable thing here is a void now. Well, actually it's not. It could be anything. Actually, left could be, it could be anything actually. So I will actually, we probably don't really need this because we're not even gonna use left. We're just gonna use whatever it outputted. We're kind of using like the return value, so to speak, of left, which is in the capture and not in this. Strangely enough, like this value here is not really the output. This is the output that we're trying to grab, which is what's going out to standard out here. And now yeah, so now we should be good there. Now the init with stream we need, which is not left.stream. What this is gonna be is, I guess, this is forwarding the stream to the thing, and really what we need is we need a reader on this thing. So let's grab the rider. So this is the capturing rider. However, this is like the ref. So let's do ref. Capturing rider is gonna be this thing. That's the capturing rider. All right, that's our rider. Except it should be var. Well, no, this is a pointer. Why is this a const pointer? Pointer to a const. Not sure. It shouldn't be. This should just be a pointer, and then yeah, it shouldn't be a pointer to a const. It should be this, like weird. Okay. And then you are the capturing rider. Okay. So now we have the rider. And it's writing into this allocating thing. So we also need to get that, the allocating capturing rider implementation, basically, which is gonna be this part. We can put you there. Now you're the allocating, and now we can say that you are the rider. There we go. What if we remove this? Is this still const? That's so weird. That shouldn't be const. Okay, well, anyway. That's just, I think that's just a bug in LSP or something. Okay. So now we can maybe try to make some kind of reader out of this. That's the plan, at least. So capturing rider implementation. I think the issue here is that we don't really know when this has been deinitialized, and that's kind of when it should be closed, right? So it's closed like whenever this stops writing and closes, we should close this, which then closes this reader, which then should, you know, close the whole chain. So that's also a thing we need to figure out. And that's not really... Like, what does this do? This freeze and then sets to undefined. So there's no way for us to check, you know, what this thing is doing. Like... No, so we can't really know what's happening there. We could make we could make just a wrapper around it that will try to that you can set completed on. And we still also need to connect this, whatever happens in here, we still need to connect that to this then. Because if we spawn a child and the child closes, we need to know which riders we need to close. So I think we need to kind of be able to set things on these to make them stop or be like quote unquote closed. I mean, maybe they shouldn't even be writers and readers. Maybe they should be files instead. They should just be files or something. I don't know. Actually, well, let's just say that we just add a little thing here. We just add is completed or something. And we'll have like a close. And that's it. Okay, so now we can track that. And I guess we need one for the reader maybe as well. Well, couldn't hurt. Okay. So now it's like every time we stream, every time we create a child process that's set up to an output like this, we need to actually there could be multiple at once on the same thing, so we kind of need like a list of things. We kind of need like a list of pipes that go into this, and when all of them are closed, then we close this. Or yeah. Okay, so let's add let's do like connections, and we'll just do an array list. Let's do, well, no, array list. Let's actually do array list. No, let's do a hash map. And it's just gonna be, it's gonna be a set of process IDs. So this is a set in Zig where you have some kind of hash map. The key is something, and then the value is void. Now this is a set because all of the values are not even gonna be stored in memory. They're gonna have 0 size. It's only the key that gets stored. And now essentially this is a set now. So that's pretty cool. Excuse me. And then we'll initialize you to empty. And we'll say close now requires process ID. And we're gonna say connections, and we're gonna do like remove, and the key is the process ID. and we don't even need an allocator or anything, and we don't really care about if it's succeeded or not. We just want to close it. Okay, and then we'll make a convenience function that says like is completed or is closed. Go, and we're just gonna check if connections has any kind of count in it. No, it has to be 0. Yeah, there we go. And now they should be like, you know, it's close is true when you first create it. You have to connect a child first to it before it kind of counts as being even open, I guess. But I mean, yeah, we could have a flag that says like initializing or something, and then once one has connected, but then if nothing connects, it should, yeah. Well, we'll see what's needed here, but this is basically probably what we need here. I'm gonna do the same for standard in as well. We should really generalize this, to be honest. Yeah, let's just make this generalized. So let's do function, and then this would be the IO type or whatever. And this would be pipe materialized. And you would be the IO type. We just add a little bit of safety here, I guess. If IO type is not equal to standard IO writer, or IO type is not equal to standard IO reader, then we get a compile error saying that IO type needs to be either an IO writer or IO reader. So if we get some kind of, we're probably gonna get other errors as well, but this really says what the issue is. Okay, and that's the IO type. Yeah, okay, sure. Let's do this. And then this would be the IO things that now. Alright. Close is closed. We also need like connect. Which means we actually also need an allocator. And here we could just put that in there. We'll have some kind of allocation error. And we'll do a try. Okay, now we can remove. And these will now be pipe. So basically pipe writer. Well, let's capture that materialized. Let's do like word so we don't capture something weird. And this would be pipe materialized, and then this would be whatever's in here, but then we also have standard IO. There we go. Oh, and there you go. There's some kind of weird issue here. So what happened there? Oh, it matched. Well, okay, so we have to have at least one here. There we go. All right. Cool. I mean, I guess technically we could also try and, you know, not have to type this. We could also just do this actually. Where's the thing? Pipe materialized. Let's do pipe rider materialized. It's just so that I don't have to do 2 implementations. And then reader. There we go. Okay. So now we have connect, which connects a child to this thing. The child can also close, and then we can also check if we are closed or not. So now we can hopefully properly clean it up later. Yeah, the thing is though, this right hand side, if this spawns a function, let's say, or I mean a executable, we need to wait for that here. So we create these things, the frame around it. We have to call this right function and wait for it to complete as well. So maybe we need some kind of special evaluation of this here for that. It's gonna be a blocking evaluation of this function call, whereas this left hand side is not blocking. So okay, I'm just trying to wrap my head around everything that's supposed to be happening here. Okay. Right, so we have our rider there. Now you should be connecting to that rider. I guess also, yeah, okay, let's just wrap this up, the left hand side. So when we do an executable, and it will connect to standard in somewhere here. What the hell is this? This is something else, yeah. So this connects to that. Man, we should really work with the pipes. The child standard in. No, okay, so that's the child stuff. Okay. So where is the actual thing? It's this one. Right. So that's that, but we only get the reader out like this. Also, this is wrong now. This is gonna be like IO. So let's actually, instead of doing this, we're doing this. There we go. Yeah. And these should all be vars. No, they should be consts. The thing is, we should get the pointers to these, I think. Maybe not actually, because this should be pointered, and this as well. So maybe we don't need the pointers actually. Okay, but anyway, that's that. Now, no, we do need pointers because that's gonna affect other things. Yeah. This has to be the pointer to the thing. But where is that stored though? That's stored in some context somewhere. Yeah. And you have to be pointers here. So that's gonna be that. We get the forward context. This has to now be a pointer. And we return the pointer instead. Okay. And we're doing that. Now that should be all pointerized. Okay, cool. Okay. So we get the pointer and then we return standard in. Wait, but that's pointer 2. No, this is not a pointer, right? Right, this is not a pointer. This is the pointer. Okay, okay, that's why. I was not like, why don't we get errors here now? But yeah, okay. So now we get pointers to the pipes, so we can actually, you know, modify them directly. And man, those pipes really need to be, they probably need to be like, because what if you do like a background thing? I think if you do a background thing, that whole background thing is gonna be like detached from the scope and put it in its own thing. But I'm not gonna worry about that right now. I just want to make the basic thing work. Okay. So now we're down here. What we need to do is we need to do like, if we have standard in, which is the pipe, we get this and we say connect or not. Wait, what's happening? Okay. They are not nullable anymore. I forgot about that. So why wasn't this an issue before? Maybe because there was other issues. Okay. So these are not optional anymore, actually. So these ifs doesn't make sense. Or does it? No, it doesn't. What we need to do instead is check if this is blocked. No, that's not correct either. If standard in is not closed, there we go. If it's not closed, we will forward the thing. There we go. Standard in IO. And that should be the reader. Yeah. Except it's null. Oh, okay, I'm stupid. Okay, the standard in, okay. IO, there we go. This is not optional. Okay. I'm crisscrossing my thoughts. So we just say connect here. There we go. The allocator is self-allocator, right? We just do it for everything. We just connect to all of them. And then standard in is closed whenever the reader has end of stream, right? Makes sense, yeah. And whenever standard in closes, we also close the file of the standard in writer on the channel. Yeah, that makes sense. We should also disconnect standard in as well. Actually, we're connecting. No, it should be the writer that connects to this. No, I'm confusing myself. Do we even need this? Man. I think my idea at first was to use the streams for this instead. Like use the stream because that can... But no, we need to know when a child has, when the standard out is closed. That's when the reader of the child has closed, right? So then then that's closing the reader, which also closes this thing. Okay, let's just continue here and see if we can make sense of this. There's too many moving parts to keep in my head right now. Welcome back, Penguin. There are too many things happening. Okay, so we connect those. When this closes, we also do not try. We do standard in close child ID. Well, I guess we could do that down here maybe. Like if we close, this is closed anyway, so we don't really need to. Well, could this affect standard out? Yeah, I guess it can. But then we would know anyway. Yeah. The process knows that standard in closed, so then it should close this by itself. Okay, well, let's just put this in here. Standard out close. Okay. Well, we're still up here doing stuff. But yeah, now we have kind of connected that. Right. Okay, but we're still kind of in this function, we're still kind of waiting for the thing to end, basically. We have this while true. Now, this is not really what's going to happen, actually. Yeah, okay, this whole thing we need to change. Yeah, because this is going to block until everything is done. That's not what we want anymore. That's okay. Yeah, that's the whole thing that we did before. Like, this is actually going to be wait. Yeah. Okay. 1 second. Oh, excuse me. Yeah. Okay, now it's coming back to me. So basically, when we call wait, it's gonna wait until the process is killed. But what we're gonna do now instead, we don't really have the let's forget about this finished at and all this crap here. Where's the started at there? Yeah, forget about that. Okay, so this child is born. This doesn't actually run the process. We're setting up a bunch of stuff. Now, we don't do wait, we do wait for spawn, which won't actually run the process. It will just do some extra bit of stuff, so we know that, for example, if the command wasn't found or something like that. But then but it's gonna start the process, and then it's gonna, I hope at least, wait, I did test this. I think this is starting the process and waiting it to be completed, and then we call wait when we know that we can close it. So, or when we need to wait for it to complete. So I think we're gonna have two versions actually of this function. Like this function is probably gonna be, well, okay, the function as it is right now here, this is like the blocking. This is blocking. So actually, let's rename you to evaluate executable expression blocking. So this will wait until the process is done. But then we need another version which doesn't wait until the process is done. So I will just copy all this. Or potentially we provide like an options. Well, let's just copy it for now and we'll figure it out. It's easier to do. And then we'll call this non-blocking. And now is the question what we do here though. I guess it's kind of confusing to have these blocking, named blocking here, because they are basically closed, not blocking, I guess. But whatever, I'm not gonna change that right now. Child didn't, yeah. So we're spawning and we're setting up everything. Now this is one I'm not really, I need to figure out what to do here basically. I know that we should do wait for spawn. That thing I do know. I do, but this we don't do actually also. We don't do this, but we have to have some sort of mechanism that will read, that will actually try and, you know, do the thing. Actually, you know what? Maybe we could return a process here. Hey. Process. And this would be the ID. What the hell? Okay. So this would return the process ID. Yeah. And then we don't do this thing, but we will connect, but we don't do this. I'm just gonna do this for now. Actually, you know what? We could take whatever's happening over here and also over here basically, and put it in a separate function that will be like wait for process or something. Wait for process. ID. Okay, what else do we need here? Well, we can get the child from the child map. Get ID. If it's null, I guess we don't do anything. Alright, so we got the child. Now what do we need here? We need like the pipes. Maybe, well, we could, I think, yeah, we need to supply actually the context. We need to supply the forward context here because that might have been lost. So let's do forward context. It's gonna be scope. Let's do like materialized forward context. Where's the scope at? Oh, it's on scope. Okay. So scope stack materialize forward context. Oops. But actually, it could have disappeared then. Maybe. No. Yeah, because we push the frame before we call left. We pop it after. Then this is gone. I mean, I guess we could detach it if we could detach it. Yeah, yeah. Okay, so we detach it. That's fine. Right, so we have the forward context. Now we can get all the standard in and out and everything. Let's just do. Well, these are just pipe materialized, so it's just gonna be like standard in equals forward context. Oops. Standard in. Oops. Okay. And we need these. And then we have these files as well. Let's grab those. Anything else? Not sure. Yeah, and then that's just gonna be, you know, the thing. Should we return the term signal then? Yeah, we'll just return process term or child term. There we go. So now basically this guy, this thing over here, we can just say forget all this, and the term, we don't really do anything with the term, so we can just say this and then self wait for process and child ID, and then we should, the forward context is really, you know, we instead of doing this, we could just get the forward context. Instead. And well, copy that. Okay, and then we could just put this over here. All right, cool. I guess we'll do that try. Okay, a little bit easier to reason a little bit more about what's happening. There's when a function gets so busy, it's always like very. It's easier to reason about what's happening if you section things out, and not having to have the whole thing in your kind of context window. Now I understand how AI feels. Okay, so that's wait for process, right? Yeah. Maybe we should also check. Should we really connect to standard in? That's the thing. Like, or should we just check if it has closed and then close this when that happens? But the reader should close though. Yeah, it's the thing that standard out is. It should like. Okay, well, we'll figure it out. Okay, so now we have this wait for process there. You will just return that, and we don't do any of these. Do we do connect though is the question maybe. I think we do. Okay, but we don't need any of this. And right, let's do the same thing here, like forward context. All right, now it's like this part is also common, so let's just put this in like spawn process. Which will give us something. I don't know. Let's see what it gives us here. I guess we just return the child. And what do we need? So these are needed. We do need scopes as well. Okay, and we just return the child. Right, so now we could just say well, let's keep the logs. So this would be like const child is equal to cells spawn process. And of course we need to know what we should spawn. Well, actually it's part of the context because it's like we get the argv from the context. We don't even need to pass in anything. All right. Yeah, we just grab the argv from scopes, and that's what's gonna happen there. Now, standard in, standard out, standard we don't really have, so actually we do need to capture the forward context here as well. Although we should probably connect way, so we don't really need to do this here. Actually, we can actually do that right away here. So we don't need to like use that. Okay, and then URI try, and then we just wait for that to spawn. I guess we should wait for it to spawn anyway. I mean, yeah, we could just put this in here. Why make it into a separate thing? We just wait for it to spawn. That shouldn't return anything. No. So that could just be an error here. And then we return the child. So that's it. Okay. So now this function is a lot easier to reason about. Non-blocking, we just spawn the process and we return the child. But it's not waiting for it to complete. Okay. Now, and then wait process will actually do the waiting and also streaming. Maybe that should be in a separate thing as well, because then we could potentially put that in a thread. Excuse me. I don't know. But now this thing, all of this is child, no, spawn process. And then we wait. And that's it. We don't really have the forward context though, but we can get it. So we can get forward context from scopes, and there we go. And we'll just remove this. All right. Cool. Okay, back to this horrible mess. Man, it's just like when I'm in one place, it's like, yeah, now everything makes sense. We do this, we do this. Once I get back here, it's like the whole house of cards falls apart. I'm just gonna refill my coffee. I'll be right back. Okay, let's see if we can make sense of this now. So, things in here get spawned with this frame forwarding context. Okay. Standard in is blocked. Standard out is initialized with this writer here. So everything that this is writing out should be captured in this writer. And the writer is an allocating writer, so it can potentially hold as much as the memory can. But then we just need a mechanism for which to extract that as well. And yeah, that's what I was trying to do with like the reader-writer stream interface. But okay. And then we have the write expression, which now is supposed to be blocking, basically. What we want to have when we execute this is a child ID that we can wait for. Or it could also be the executable expression itself. But the evaluate is supposed to evaluate everything. So I think the best solution is probably to just say that, okay, if you have an executable, we're not going to do the blocking. We're going to do the non-blocking. which will give us the ID of the child, which we can use. So basically, well, it's a function, so the actual execution part will happen here. This will just evaluate it into the function that we call to get the process ID. Yeah. Potentially, like it might not even be a process ID. It could just be, it could actually be it could be a function. It could be any other function as well. But if we get a process ID, we need to wait for it here. So we might need to check what kind of function it is before we call it actually. Which we can do. We can check the expression. We can say, you know, we can switch on the function body. Oh, it's a ref, right? So we need to get it. Let's get the, well, no, let's get it. Okay, so let's get the function declaration. Well, this is the actual ref here, or the payload, I guess. And then we can switch on function declaration, body star, and if you are an executable, now we, so this is kind of a like a special evaluation here. We're trying to check if we have an executable, because then we should evaluate it. And well, actually we could just do the blocking one in that case. Blocking parts, yeah, because this is supposed to be blocking here. Oh, also we need to surround it with, we need to actually do the call. God damn it. Actually, is the body a call or a just a, no, it's a call, right? It's supposed to be a call, that's right. It's a call, but the call, the only thing in, wait, and then the callee is the executable. Yeah, I'm pretty sure. And this discards the thing from there, so maybe we shouldn't actually do that. Maybe we should actually return the, oh, okay, so this doesn't really give us a value. Okay, well, yeah, we do need to run the function, and we do need to kind of capture the man, this is, this value just gets lost here, because this function, this has the executable expression in it, which then gives us the process ID in the value, which we then deinitialize here. Okay, well, we, evaluate call expression, yes. So we basically need to, what are we doing here actually? We're getting this should be a function, right? So that's what we're trying to do. And then we're also like dealing with arguments here. Yeah. We're evaluating all the arguments. We are running the function itself. Here we're kind of pushing, we're pushing some frames, everything that's needed to run the function. The thing is though, for executables, you don't really need that much. You just need, well, you need the arguments. But then when we evaluate the executable and we spawn the process, we actually get argv from the thing. Okay. Right, actually, we could just declare a function. We could just declare the function arguments with the variadic because we know it's variadic. We have the function declaration. Yeah. So we do that, and then we just evaluate the thing, and we can push a scope if we want. We don't need all this crap. We could actually make a separate thing here that's only for executables, like run executable. If we know it's an executable, how do we know that though? We don't really know that. No, it could just as well not be, I guess. Okay. So this is a function. The problem is just that we need to be able to get the child that's spawned and wait for it. That's the whole, that is what we need. We could try and make it happen through the context, I guess. We could make a context that captures whatever child was spawned or something like that. I mean, that would work. But, yeah. Arguments. Wait a minute. Is this even a function? This should be like a... Yeah, it's a function. Yeah, it's a function. No, and then there's no arguments. Yeah, these are always have no arguments. The thing on the right hand side always has no arguments. That's right. Because it's a pipe operator, we automatically create a function with no arguments that takes the standard in. And yeah. So this is just empty. That's right. There we go. Okay, now the only thing left now here for this specific thing is to grab the ID of the child and wait for it to end. The thing here though is that run Wait. Are we actually running this function? I guess we are. We run the function. This pushes a bunch of frames. We declare the arguments. We evaluate expression inside, but we just remove this. We don't really need this, right? This is like super unnecessary. We should just return the value, to be honest. We should just return the value that we got from the thing. And if it's a void, it's a void. If it's something else, it's something else. So we just return this. It's not really that big of a deal. And we don't really need these things. That was just for tracing, I think. Where move to clarity. Oh yeah, so now we don't have recursive anymore, but whatever. We can fix that later. Fix recursives. Okay. Fix recursive functions. Just to have some information there what's happening. Okay, and then this would be a value now instead. Right, so now we should get the value out, and we need to check, okay, is this value going to be a process ID? We also need to initialize the value. And so we switch on that. And we check if this is a process. We get the ID. Otherwise, we don't really care. We don't do anything with this. Okay, but if it's a process ID, now we have to wait for the process. And we also need a forward context. Well, it should just be the forward context what we already have here. No, wait, what the hell am I doing? Yes, yes, this is true. Yeah. So this is the forward context on the right-hand side. Okay. But now we also need to wait for the left-hand side. So how do we do that? I guess we could also check if this is a process ID. I guess that's why, that's how we do it. Like we just check, okay, is this a process ID? In that case, we wait for it. Maybe. Because we need to be able to stream this somehow. But then it's like, okay, well, if both are, yeah. No, we're back to square one here, I think. Because the problem is now we need to be able to funnel the actual streams into each other, but we only wait for one process at a time. Oh my god. Because, yeah, I've been thinking about having... well, I mean, what you could do, you could like loop through both of them, and like instead of when we do wait for process, well, I mean, we could try to do this, but for all of the processes involved, or all of the things involved. And really we need to generalize it so it's not only for processes, it has to be for functions or streams. That's really what we need. Like this is the forward process for, this is the forwarding thing for only for children. We need something that works for all kinds of streams. But I feel like we've made a lot of steps towards the correct solution here. We're able to spawn this process without it like blocking, you know. And then the right hand side, it's like it has the correct structure. We just need a little bit of the glue to make it work. I just feel like we should be able to spawn these things and let them run in the background, and it's just here that we need to, okay, well now we need to wait for this process to complete. But we also need to be able to actively funnel the data through. That's what's missing right now. Actually, you know what? This might not work, actually. Okay, let's look at this example here. Whoops, did I say what happened? Did I just quit the whole thing? Okay, let's look at this example again. Come on. Okay, forget about all this crap. So, in this example, basically these two statements are the same. So you can look at this the same way here. But I'm just doing this for for like demonstration purposes. So basically, when this expression gets evaluated, right, we enter the parentheses, okay? So in here we have one expression. Well, we have one expression. It's this expression. This is the binary expression. This is the left-hand side of the binary. Here's the operator. Here's the right-hand side. Okay? Now, first what's happening here is that we are evaluating the left-hand side, right? Which is this part, which is itself also a binary, where this is the left-hand side, operator, and right-hand side. And then we go again. We evaluate the left-hand side, right? So this one we actually execute, which means it's gonna get forwarded into this capturing writer here. And then piped into cat, right? So the next thing that's happening is that we call the right-hand side, which is cat. And then we try to, if we now try to wait for this to complete fully, like exit, that's not gonna really happen. Or it's not supposed to happen. Like, so what's gonna happen here is basically we only care about this small part of the whole pipeline right now, which is not the case. Like I was thinking, I don't know what I was thinking, but basically this would be the effect here. We need to wait until all the way at the end of the entire pipeline until we can actually start to wait for this. But I was thinking, hey, we just need to wait for this to complete and then we can pipe the result into this. But that's not really the case. Like when we wait, that's when the whole statement is run through, or the whole like start of the, like the root of the pipeline, the root of the pipe binary basically. So it's like even if we have a pipe binary here, that doesn't mean that this pipe binary should wait for anything. It should actually run in the background basically, asynchronously. But this one should. So there's a difference between this pipe expression and this pipe expression. It is context based. So we have to have more context in order to know if we're supposed to wait on the right hand side or not. Because when we're out here, then yes, we do want to wait for the right hand side because now we're at the end of the pipeline. So we could do either, we can change the pipelines to flatten them so that we know that we have a list of things that we need to worry about, or we can add some more context to the pipeline so that the last item would know that it's the kind of the root of the pipe binary tree, and we can then say, hey, you are the root of the tree, so you're supposed to wait for the thing. Now we could also do it with context. So when in the execution context, when we get to this, we know that we're currently not previously in like a pipeline thing. Actually, we could be probably. We could actually, you know what? What if you had an expression like this? You have like hello, and we will. But no, but that's an argument though. Let's do a whole thing. Let's do like. I mean, what if you just have this, like echo hello, and then we just, you know, we have this, and we just add hello onto it after, but that appends hello in there, so that doesn't really count. We need to now we need to evaluate this whole thing before we can actually append here, so that doesn't really work. It's only pipelines, I think, that are gonna be working like this. Yeah, I think so. Because as soon as you have something else, that needs to have evaluated fully before you do anything. Like the pipelines are the only one that's kind of working with streaming behavior, basically. Like the pipelines and the like redirections. As soon as you have any other binary operator or other expression, is gonna be blocking, basically. Okay, so then, but I'm just trying to figure out. So then it's basically like, okay, well, then we can say that once you're in, when you come from a non-pipeline context and you encounter a pipeline operator or a pipe binary operation, we now enter a pipeline context. Okay, and we also keep track of how many, you know, levels we are in. I guess you could do, because if you, so first here we push like a pipeline context. Okay, now we have to know if we are in the pipeline. I guess we could have like a pipeline context, a barrier, a pipeline barrier, and then a non-pipeline barrier. So you can also leave the context. Like, for example, if you're in here and we say, you know, echo hello in here into cat. Now that's also a pipeline that's within another pipeline context, right? So now we enter first this. Let's just consider this. When we're outside here, we have no context. When we enter this, we now push a pipeline context. Okay? And then we go in here, and this is the left-hand side, and this is the operation. So this is the left-hand side, and this is the right-hand side. So we're still in a pipeline context. So now we're kind of pushing another level of pipeline in here, I guess. Well, or we reuse the same context and we just add a depth to it or something. Okay? And then we evaluate the left-hand side. Okay, that's an echo, and that this argument is going to get evaluated, which means that this interpolation is going to get evaluated. But now, since we're not in, this is no longer a pipeline context. Now we're in like just an ordinary expression evaluation. So now we should like move away from the pipeline. We should push like a pipeline, like a non-pipeline context or stack on the stack or whatever. And so when this gets evaluated, now this is now counting as the first of this particular pipeline thing. So we're pushing a pipeline context here, but it's the first one of this thing in here. And then we just repeat the process. So this was the left-hand side and this is the right-hand side. And now we know that we're in the root of one pipeline, so we should execute the whole thing. and that gets evaluated into this string, which now this whole thing is can get evaluated into the background process, whatever. And we do this, but now we know that since we what happens here also, like when we get out of the pipeline, we also pop the context, of course, or pop on the stack. So when we get out here, we also pop the non-pipeline thing. And so when we get that over here, we actually are in the old pipeline context now, but with depth like 1 or something like that. So we know that, okay, we're not in the root of a pipeline, so we shouldn't wait for this to complete. We should just spawn it and hook it up, and the result is then put forward here, which could be the process ID of this or something. I'm not sure actually, but we get this, and then now here we now know, well, when we get out of here, we also pop the context. And so when we're out here, we now know that, okay, now we're in the root of a pipeline again. So now we have this has been evaluated, and then this will get evaluated, and then we know that we need to wait for this to complete before we continue execution. So that could be the way we could do it, with using some kind of context stacking mechanism. The only issue I see here is basically we should allow certain expressions to be evaluated before we kind of say that, hey, now we should, you know, enter another type of context, maybe. Or maybe not, actually. Every time we evaluate, we should maybe check if we're in a pipeline context. If we are, we push a barrier. How would we know to pop it after though? I guess we could use the same logic. We just check. Well, we check before, and at the end of the function, we just pop it. Yeah. Yeah, that's fine. And then once we get in pipeline, we push the pipeline context if we don't have one already. Yeah. Okay. So let's do that. Also, can we? I'm pretty sure we can ASD this one. Yeah, that's fully ASD, so good. We're already done with that. Okay, well, let's go to our dear old scopes. And let's add a new type of frame, which is the pipeline frame. Well, let's just call it pipeline. Pipeline. And let's just make a little struct here. So let's just add like a depth, start at 0. And I guess that's it. We could add more things to it as well. I mean, we could keep whatever context we need here. Yeah. And then we also need like the blocking thing. It doesn't really work here. We need like a pipeline blocker or something. So that we know if we're in the root of the pipeline or not. I think this is gonna, it could get hairy, this part. Man, it probably maybe better with some other solution. Like, I mean, maybe it's better to just try and flatten it in the parser, actually. Like we do with the, whatever it was. What expression did we flatten? Oh yeah, it was function application, right? Function application we did flatten. We could also flatten the pipelines. It does make sense. I was just thinking, hey, we should be able to create like a stream here and then here. It's just a problem when you get to the end of the statement, you have to kind of wait for the thing to complete. I mean, maybe that's the thing. Maybe it's like, okay, well, if we say at the end of a statement, no, but that it doesn't have to be end of the statement. It could be part of another expression. Okay, maybe it's better to flatten it then, because now we know that, okay, we have one pipeline. We should just spawn up everything and connect everything to everything else, wait for the thing to end, and then we can also, if it's async, we can also just detach the scope, put it in the background, and just wait for it at the end or something like that. Yeah. Okay, let's do that. Let's do that approach. This doesn't work. This approach doesn't work. We need to change it. The whole scope thing is also like, well, it could work, but it just complicates things a lot. Like it's probably a lot easier to just flatten it in the parser. We have now the pipelines are always a list, and we just, you know, evaluate the whole list at one go. It makes sense. All right. Just because of that little tiny detail, like we need to wait for it at some point. I mean, maybe we could have, no, I was thinking like maybe we could have like an operator that says like, hey, should we wait for the thing? No, but otherwise it's always gonna be async. No, that doesn't make sense. I mean, we could, no. I was thinking maybe like expression, evaluate expression could have like a blocking variant, or a non-blocking variant and a blocking variant. No, parse binary flatten. All right, we just need to add, so we have apply, we just need to add a pipe here. So I'm just gonna copy this, say pipe, and we're done. No, we're not. This one is checking like, okay, left has to be a call and so on, but let's see what makes sense for a pipe. It could basically be anything. The left hand side could be anything potentially, like anything that can be coerced into a stream. And right now we should just enable anything to be in a pipeline, and then the type system would have to check what's possible or not, and the execution. So let's see. We'll do this now. This whole thing, what is this actually happening here? We're taking a binary expression, we're checking if the thing is apply. All right, so it's like if left hand side and right hand side, I think it's like the left hand side, we need to check if the left hand side is already a pipe or a binary. Yeah, if it's a binary, we already get the binary in here. So this is like the left binary, left hand side binary. So if this is a binary, we also need to check the operator. And the operator has to be a pipe. Then we flatten it. Otherwise, we return binary. Yeah. We return the original here. Okay. Now what's going on here? I don't know what's going on here. I'm just gonna return the original expression. Right, so if left is not a pipe, it's binary. If the operator is not pipe or apply, we return binary. If the pipe left is not a binary, we return binary. If it's a binary, we check the operator. If it's also a pipe, now we can flatten the left hand side with the binary expression. So yeah, but now this is no longer, well, we need a pipeline expression. So well, we have a pipeline expression. But I think we need to change it. So let's go to the AST, and we have the pipeline here. So we need to change this a little bit to work with whatever we have. So basically, yeah, this whole thing is a mess. We have a bunch of stages, which makes sense, you know, pipeline stages. However, these are not going to be like pipeline stage. This is going to be just an expression now. It's just going to be an expression, and that's that. So this is just going to be an expression. We don't need to do that. So there we go. That's the thing. And actually, you know what? I'm gonna say this is deprecated because it's used in a lot of places. So I'm just gonna do this for now, and we'll copy this and change this to expression, and the type of the pipeline. Well, I'm not going to worry about this. I'm just going to return null for now. There we go. Right, but now, where's the pipeline at? Oops. There we go. So we'll take you and rename you to deprecated, and we'll have you, and you are the pipeline. Okay. We have a bunch of issues, but all right. So this is gonna be, what's happening here? This is an expression, except it's not like allocated. So, but what we need to do is we need to say this is a pipeline. Actually, oh yeah, that's why we do this. So we also need to convert, like in the case that this is the first pipeline, right? We need to also create the thing. So if the left hand side is not a binary, just like this is not a call on the left hand side, something else, then we create the first call. We should create the first pipeline here. So this should be a pipeline. So the first pipeline is going to have stages, empty, or well, it's gonna have like the stages is gonna be left and right, actually. So let's do what? Oh. No, this is just gonna be binary span. Okay. Sure, let's do copy to arena. The type is expressions. No, it's that. The values are left and right. So that's gonna be the first stage, or the first pipeline is like when you have left and right, right? These are expressions, yes. So T, we get a bunch of T's. Okay? We also need to try that. So that's the first pipeline. Then, when we get other things, and the left-hand side is actually not a binary, but actually a pipeline. We get the pipeline here. All right, now we actually need to figure this out. So we just concatenate the previous one, but we also need to, well, yeah, whatever. It's a copy to the arena. We can just concatenate. Where is the thing? So standard mem concat. T is a expression. Slices are gonna be pipeline dot stages and then the right. Okay, so they were flattening that, and then span is gonna be pipeline. Well, since the left hand side is a pipeline, we could just do binary span because that should include everything. There we go. Oh, but that's not okay. Well, we need to make an array of this, or a slice there. There we go. I wonder if you can you omit this? Does that work? No, you have to have an ampersand there. All right. So what is happening now? All right, so every time we encounter a pipe operator, we check. Well, first we initialize with left and right, and then when we get next one, we will check if we already had, like on the left hand side, already had a pipeline, and on the right hand side we would have the next in the stage, so we flatten that. Okay, that should work. Now it's a little bit not optimal with the memory usage here, but whatever. Okay, so now we should have like flattened pipelines, and if we go back to the evaluator, now we don't actually have binaries here anymore. We should do something akin to this for pipes as well. Oh, there's a typo here. Actually, we could do T and then expression or binary, yeah, dot operator. So then we can do this or pipe. Okay. And now this whole thing is gone. Well, we still need to kind of do something here. So we need evaluate pipeline, which we did have before, but now it's like actually implemented here. So all right. And this is the pipeline. Yeah. So now we don't just have like left and right. We have a list of things, and yeah. It's gonna get a little bit hairy. I just need to be 1 second here. Alright, let's try and make this work. So, okay, so, well, basically, I mean, really, we just need to, we kind of just need to make this into a loop. Okay, well, this is gonna be the first context. So this is the first context here. And then the right hand side is not necessarily the, well, that is, yeah, this is gonna be the last context because it has like inherit here. Man, okay, now I need to think about how this should work here. Let's open up the example again. Okay, so basically, let's do the easier example here first. So now we have something like this. So we encounter this, right? We're setting up this, we're spawning this, setting up a context around so we can capture the output. Next up, we should spawn this, connect, standard in from this. So we spawn it, so we create a new another context that surrounds here. And, well, not necessarily, I guess, but, well, no, yeah, we don't need to pop the context or anything. We can, we create a new context. Well, really it's going to be surrounding the whole thing, which is blocking standard in and standard out is being captured. And then we create a new context around this, which
connect standard into the capture, and we're capturing the next stage. And then another context here we captures, which inherits because it's the last stage. So either we're gonna have blocking standard in and standard out is captured. Standard error is always inherited right now. Both coffee and tea in the same cup or in different cups. So the first one is like blocking standard in, standard out is captured, and then each step along the way is going to be connected standard to the capture before, and standard out is also captured into the next one, and that the last thing is going to connect to the capture of the previous one, but now standard out is inherited instead. Well, it can't be inherited though, because now that needs to be like the last context in that case. So we kind of need to go backwards actually. We need to like create a rider for standard in on the last one. And then standard out, standard error is inherited. Then we go backwards, spawn this one in a context that captures the output, and then that output will be put into here. And we also create a rider for the standard in here. And then we go backwards there, create another context for this one, which will capture the output and put it into the standard input there. And here, because it's the last thing, it's gonna block the input here. Alright, see you later, Penguin. Yeah. Okay. I think maybe I want to make another function. This is just too busy in here. I'm getting cross-eyed just looking at it. Well, first off, I want to create this. I want to add these things. Let's also do this. So we enable it. Okay. Okay, I think that's what we're gonna do. We wanna go like backwards. So get this out of my sight. So we'll do like we could do like a while loop or something like that maybe. Or we could do it recursively as well. Let's try doing it in a loop first. So let's do like for pipeline stages length. Okay. So index is gonna be pipeline stages length -1 minus I. That is the index we are worried about, and so the stage is going to be pipeline stages index. Okay, this is the stage we want to now evaluate. So evaluate expression. Whoops, today's is stage. Okay, so now we've done that. We evaluated that, and that should produce, like, if it's a call to a function that gives us a process ID, we should get a process ID that we then need to wait for if it's the last thing. What if the last thing is a function? I don't know. I guess we haven't really gotten to that point yet. Like, if we have a function, I'm not even gonna think about it, I don't think, because the thing is, like, when you execute a function, it should be connected to some kind of standard in, and we don't really have that right now. We don't even have the possibility of doing that right now, but in the future, like, it's gonna be possible to have a function that's connected to standard in, and if it tries to use standard in, it has to use it in like a pipeline expression somewhere. So I think what's gonna happen is we evaluate this expression, which is a function. Actually, this is a function call. I just realized, man, that needs a standard in. That's the thing. Okay, well, I kind of built this to work the other way around. So how would this work now? Because this is like a function that takes standard in right now. But really, we don't need that. I don't think we need to wrap it no longer with a function then. We evaluate this, but before we do it, we wrap it in a context in which we have a reader for standard in, but it won't be able to kind of consume this reader until we've set the rest of the thing up. Yeah. So actually, we don't need to wrap these in functions right now. I think I wanted to wrap them in functions because that's kind of like it's gonna be the kind of common. It's gonna be like the generic type that you always have a function like that you can connect with a standard in, basically. I think that's why I wanted it to be a function, but really we should just be able to evaluate cat, but then just connect standard in, and that will make it understand what it's supposed to do. Like, yeah. We can just evaluate. Okay. Oh my god, I just exited the whole thing. Okay. Oh man, this has been a roller coaster. This whole pipelines thing. It's gonna be incredible when we get this to work. Right. And you go back to the you went from the drawing board back to work, and the mind just went blank. And it's such a common thing. It's like when you get like, you see things from higher level, and it makes sense if it works like this and this, and then you go back to the actual detailed level, and it's like, wow, okay. Okay, but right, so we evaluate the thing, but before we do that, we should have a context. So we do scopes, push. We also need to add scopes here, I think. That's it, yeah. So we push a forwarding frame, and the options are going to be standard in is well, it's not blocked. We can initialize with a reader. yeah, so we need some kind of reader for that. So this would be standard in reader. I'm not exactly sure. Sure, let's do streaming. I haven't figured everything out yet. Standard out is gonna be inherit. Standard air is gonna be inherit. Now the thing is, standard out is inherit, but that's just the start. So I think what we'll do is we'll keep a thing here which is standard out. And first we're gonna say that this is inherit. And this is like scope stack pipe material writer materialized. Right. Pretty sure you can say, oh no, this is the reader, right? This is the wait, or is it? Oh no, it's not materialized. It's just pipe info, I think. Pipe. Where is it? No. In here, pipe writer info, but it's not public, so we need to make it public. Pipe writer info. There we go. Now we're cooking, because these are pipe writer infos. Yeah. Okay. And then we also do standard in should also be, yeah, standard in is a pipe reader info, which at first is going to be initialized to well, actually, first we don't really have one until we're down here, I guess. No, let's not even do that. And standard error is always going to be inherit. So this would be the standard out. And this would always kind of do this, except if it's the first one. So here we do like const standard in is a scope stack pipe reader info. If I is 0 or more than 0, let's do the normal case first. Then this would be init. Sounds like standard in reader, streaming, whatever. And then otherwise, it's gonna be blocked. And then you will be standing. There we go. Oops, daisy. Oh, okay. All right. So that's gonna be like reassigned every loop. First thing is gonna be some kind of reader. The reader we will create and then try to connect the next time around. So we need to keep this reader around here. Now the reader should be a standard iReader, yes. Which we just say is undefined for now. And over here, well, okay, I guess we'll make it optional, because the first one, we could either make it optional or we could say, you know, if it's the first, if I is equal to 0. Oh wait, no, this should be index is more than 0. But here is like if I is equal to 0, that means we have the first item. So that means we need to set up the reader to be, wait, what am I thinking? Something doesn't feel correct here. Hello, Nandu Zero. What's up? Welcome, welcome. Thank you for the follow 2 days ago. I'm not that good at reading like announcements or alerts. Well, I don't really have alerts. I haven't defined anything. I'm too early. What do you mean? Too early for what? Sorry. Standard. Okay. How will this work now? So first, we need to set up some kind of reader. I guess this would be kind of this. Well, yeah. Well. What would this reader be like? It would be like the file reader of the standard out of the previous one, I guess. Well, but no, we can't do that because it's not always a process. Like, we just need to read the previous one as a stream. So is this where we pop in our streams? Maybe. Okay, what do we need? We need to have a reader that reads from the previous thing in the pipeline, and it has to be set up beforehand, and then it's connected to. Okay, so we need like this, the reader writer stream. I'm pretty sure. This thing. Let's figure it out. Yeah, it has its own reader implementation, which is what we need, because we need to basically say that, hey, you're supposed to like read if we don't have a source connected yet, we can't really read. So maybe the source is actually like connectable. Like we have it's null first. The writer, wait. Okay, so the source is probably not a reader. It has to be like a writer. The source has to be a writer. We're taking a writer. So we're creating this stream, right? It doesn't have a source yet. But it does have a reader. So we can connect this reader to something, which is the standard in of the thing. And then we need to connect it to a source. But the source needs to be like a writer, except
it's yeah, I think it needs to be a rider actually. We don't have like a rider here. We have a rider here that we wanna like read from basically. But the thing is that the rider interface is not really meant to be read from, I guess. You could read, you could read I guess the written. Well, I guess you could get the written part and then flush it. Yeah, okay, yeah. I guess that works. Alright. But it's not, the important part is that it's like you don't have to connect it immediately. And so we could add a function called connect rider. And this one is, we don't even need anything here. Connect rider to self. And let's just put this here, I guess. We will do get parent. No, yes, get parent source equals to rider. Okay. I'll put limit here. So if we are completed with okay, let's come back to this, but basically also we need to check, we need to get the rider or the source, maybe is self.source, or else return well, it's gonna be like the empty event, which we don't really have, but we can create an empty variation here. So this would be, well, actually we could just say init next, where let's add a check here, because yeah, okay, I'm gonna do something stupid. So basically, if we have like an empty, that's gonna be like next with the payload. Wait, where's the thing? So allocator is gonna be undefined. The payload is going to be, actually, this could just be like page allocator. It could be anything really, because the payload is just gonna be empty, right? So it's not even gonna free anything. But what I was gonna do is I was gonna set this to undefined, and then down here I was gonna check, okay, well, if payload has no items, we're not gonna call this, because then we avoid some kind of like seg fault or something going on here, since this was undefined. However, we can just set it to page allocator and it will actually go in and do it itself. And it has like a, it's gonna check if the length is 0, we just don't do anything. So, well, I guess this isn't v-tabled, so we don't actually, okay, maybe that's not a seg fault, but anyway, whatever, let's just do this. Hello Ryan, what's on live? Welcome. Just saw this in my feed, so I'm new here. It seems super interesting. What's your software engineering background look like? Thank you. My engineering background is I have 10 years of, well, a little bit more now, but 10 years of web development experience, and before that I was also like I was self-taught in a couple of different programming languages, including C++, which was like my first programming language that I learned, and I've always had like programming as a hobby. So yeah, I've always been trying to build stuff, and yeah, I just feel like programming is super fun. So and this project is like, well, it's not really meant to be a super serious project, but it's a learning experience to make languages, and it's also probably I'm gonna use for my own purposes to replace like Bash, basically Bash scripts. I'm not a Bash like expert or anything, but and yeah, I just know that I don't really like the Bash syntax, and I refuse to learn it, basically. No, but it's fun to build a language, and if I can get something out of it, that's good as well. Are you a developer as well? Let's see. Wait, where am I? What's happening? Okay, yeah, so this connects there, fine. And here it's like, okay, so now we check, like, do we have a source? We return empty. Yeah, that's right. But you're refusing to acknowledge that this is empty, or that this works. Oh, we should do this. Dot. We don't need dot index. We just do dot, or we do that. Oh, we need to try. Oh shoot. Well, we have to make this into a function then. Wait. No, we don't need to try, actually. We can just catch unreachable here, because it's gonna try and dupe something that's empty. So that's not an error, I hope. No, that's not an error, I'm pretty sure. So we can do that. So now you should be just a string out of t. Yeah, there we go. So now that's fine. Okay. Cool. All right, what's going on here? So the underlying source is the writer, yes. So what we do here is we have the next inner with a limit, right? So I don't think we even need this as a reader interface to be, well, actually, maybe. Thank you. Just finished the diploma in software development. Only 3 years of experience so far with September. I use C++ for the first time working for on a few IoT devices. Oh, okay, cool. All right. Well, do you think it's fun? Software development. So, did you learn, like, was it like a broad education, or was it like focused on like, I don't know, web or embedded systems or something? I mean, I guess you would have used C++ if it was focused on embedded, maybe. I'm not sure, actually. I thought C was more common for that. But what do I know? I've never really been in that world too much,
just in my education, we had like, because it was a very broad education, so we did some stuff with robots and like, you know, that's a small, you know, robot that was a line reader robot. Basically, we did a line following robot with some network communication. All right, so what do we do here? So the purpose now is to read from the writer, right? So let's do like self. No, we have source, and then we have written or buffered, and then we flush that. That's the idea. So we're flushing this here while we are reading it. Also, what does actually drain do? Fixed drain. Okay, whatever. I'm just gonna assume that we could have something here. So we're looking at the buffered here. We could use the limit. So we have like flush default, flush. So you call drain data splat. What is splat? Sends bytes to the logical sink. A write will only be here sent here if it could not fit in the buffer or during a flush operation. Buffer ends consumed first, followed by each slice of data in order. Elements of data may alias each other but may not alias buffer. This function modifies writer end and writer buffer in an implementation defined manner. Yeah, data length must be non-zero. Okay. The last element of data is repeated as necessary so that it is written splat number of times, which may be 0. Program is pretty broad. A lot of web dev did dive into .NET Java. The program was around 50 mixed program software design. Okay, so it sounds kind of like what I did as well. I think it was a little bit more on the development, or I mean, programming side. I think I don't remember exactly now, but we did have the UML courses, which I think we spent a little bit too much time on, if I'm honest, but yeah. Super experience with embedded programming makes more sense regarding why we use C++. We made use of platform IO with Arduino libraries. Okay, well, I mean, if you're using a library that's built for C++, it makes a lot of sense. I was thinking like, well, C is more, I don't know, it feels like you're more close to the, I mean, I know C++, you're also close to the hardware. They are basically the same thing in that regard, but it's like it also has like a bunch of abstractions that if you're like tight on memory, maybe you have more control with C. I mean, you have control of C++. I know that, but I don't know. It feels like it's easier to know what things are when you're working with C. I don't know. Anyway, But yeah, cool. So is that the way you want to go, like, or are you still like exploring? Last element of data is repeated. Necessary splat number of times, maybe 0. Okay, this I need to kind of repeat so I understand what's happening here. So basically, they're saying that buffer end is consumed first, which followed by each. Okay, so you're kind of saying that, okay, well, I want to send a whole bunch of data also to the drain for some reason. I guess that's like could be used for when someone calls write and the buffer is full, it just puts everything else also in the sink if it can't fit into the buffer. So it puts everything there. But then what the hell is this splat thing? And why is it needed? The last element of data is repeated as necessary, so that it's written splat number of times, maybe 0. I have no clue what this is used for. Because it's like, yeah, you're sending stuff to some kind of sink, which I guess depends. It depends on the implementation of this. But what is this? What is this? I don't know. It might be some common pattern that I don't understand. This function may not be called if data is be stored in buffer instead, including when the amount of data is written to 0 and buffer capacity as well. Alright. Number of bytes consumed for data is returned, excluding bytes from buffer. Okay. Number of bytes returned may be 0, which does not indicate stream end. A subsequent call may return on 0 or signal end of stream via IRFet. Okay, so I just wanted to know if you could drain just with a limit or something. Or is it like discard, or like is there something you could like, you could just, well, you could do, I guess, advance. After calling writable slice creation function, tracks how many bytes were written to it. What? I guess we could do like advance. Maybe? I don't know, man. Game dev is my dream. Okay. We're working with embedded devices. Really definitely clicked with me, and I think I prefer to do that while I attempt seconds. Yeah, that's totally understand. Like, you know, I think programming can be fun, whatever you do. Like, if you find some project that you find interesting, it makes a lot of sense. Here is a Discord link, if you want to use that. You're welcome to join. So yeah, I also, that was my dream as well, or it is still a dream, but it's like, I also find programming in general extremely fun, so I'm still happy programming a programming language. Like web dev is like, sure, it can be interesting at times, but I'm kind of getting bored, to be honest. With web dev, it's like, yeah, it is a good skill to have, to be able to make a homepage, you know, that works and is like a modern and stuff. But it's also like, well, I've been in that game and I feel like I want some variation. And this is super fun. Like, making a language is extremely fun. let's see what we can do here. So consume, okay, we have consume as well. Removes the first n bytes from buffer by shifting buffer contents, returning how many bytes are left after consuming the entire buffer, or 0 if the entire buffer was not consumed. What? Removes the first n bytes from buffer. So does it remove from the start? Useful for drain function implementation or implement partial drains. Yeah, but I want to have it as well when I just want to read a little bit of the thing. Actually, you know what? Well, we don't really know how much is in the buffer actually. The drain. Wait, we could implement the writer interface maybe here. No, wait. Yeah, I mean, okay. What if we implement a writer interface as well? And then we store a bunch of stuff in a buffer, which is kind of like allocating or something. Or, okay, or we could just say that this is an allocating writer. We could also just do that. We could actually just have an allocating writer on us, right? That someone could write into, and then the reader would just read from this. Yeah, okay. Well, that's way easier. Because now we don't need to worry about the buffer or anything. We could just take whatever is in here, flush it, and that's good. I mean, I guess technically we could... No, because then we don't know if it has a buffer or not. No. Yeah, we'll do allocating, and then we're initialize. No, we don't need to do anything actually. We could just say, well, okay, we need an allocator, I guess. Oh, but we have an allocator though. All right, cool. Thinking of doing the web dev. I mean, web dev is like there's so many jobs also. Like web dev is like you could probably get jobs pretty easily. Although don't take my word for it, but also like when you want to advice there is like when you want to get a job, just like apply it to as many things as possible. You just have to keep at it. But yeah, I think web dev is like there's a lot of jobs in web dev, but I think it's like more attractive for with more experienced developers, but of course there are places for juniors as well. And if no one hires juniors, then the future of development is messed up because no one has experience anymore. No, but yeah, that's true for all jobs, I guess. I mean, yeah, web dev is like, I don't know. I can't compare it to anything anything else professionally, because web dev is like the only thing that I've worked with in development. So I can't really tell you what the differences are between web dev and, for example, embedded. So, but yeah. Even within, I think there is like there is a large amount of variation in web dev though, because there's like, you know, different kinds of, you know, do you want to do front end, do you want to do back end, do you want to do both, do you want to do a little bit of DevOps? Like, it depends on what kind of company you join, I guess. Like if you join like a large company, usually you get put into these teams and you will probably get assigned either front end or back end or full stack. I mean, it depends on where you end up. Like every company has a different way of doing it, and or you could be someone who is just a generalist who does a little bit of everything, you know. So what I'm trying to say is, like, if in web dev there is a lot of variation, so you could do a lot of different things, and yeah, if you get bored of one thing, you can jump to another thing and do that if you have the possibility, I guess. I also love like building tools to like, and that's kind of what I'm doing here. I'm basically building a tool to be able to make more tools. I'm building a tool maker here, and I think that's what I think is fun. It's like building tools. It's extremely fun, especially when you can use it later for something else. So it's not super bad to end up in web dev. It is very interesting. It's a good skill to learn. I'm just saying, like, after 10 years, me personally feel like I want to kind of broaden my horizon a little bit. But I still have, a web dev job right now because I need to work. But I don't think I will like switch jobs. But if I could switch to like streaming, that would be awesome. But yeah, we'll see what happens. Because then I can do whatever, or not really whatever, but as I can decide what projects that I want to do, basically, which is awesome. Another context near a website built as to for free. They deny me, saying they use AI site builder. 6 months later, the website still isn't active. Yeah, I mean, I think people are hyping up AI incredibly too much. Like, sure, it's like impressive sometimes. It does impressive stuff, but most often, like when you want a more when you want a project to actually work and to actually like be bug free, and well, not exactly 100% bug free, but when you want it to work and you want it to be a larger project and you want to add stuff to it, then AI is not going to cut it. AI will not help you with that right now, at least. It might be in the future, but right now it's not advanced enough for that. You have to put in a lot of work, even with the help of AI, to get something up to standard. So I think right now, like, people are hyping up AI because of all these new tools that have come out and the site builders and everything has gotten better, but it still is not, you can't 100% rely on AI. No way. Especially if you're not a developer. If you're a developer, you can use it as a tool to kind of, do some things while you're doing something other things. But then you always have to look at what AI did and kind of fix it. But people have been hyping it up and believe that, hey, you could like just use AI for everything and not hire developers, but that's just not the case right now. But people don't understand that, so they have to learn that the hard way, I guess, that AI won't help them. So then they can like be like, oh hey, could you fix this website? How long have we been making content? Also about a year. I mean, I started learning Zig and started building games about a year ago. And the idea was that I was gonna stream everything to like keep me motivated to continue building and learning Zig and stuff. But it's just been so fun to learn Zig because it's an amazing language. Also, I think Zig could be a really good contender to for you know, embedded stuff, because it's very, you know, it's low level, and that could be kind of cool. It could take over the whole low level scene. If we're a fairly simple school, and sometimes AI is best used as assistant boilerplate generator, but I agree it's not very useful type product based iterative work. Yeah, I mean it's like it looks amazing on the surface, but then when you dig a little bit deeper and you see all the flaws and all the things, and then if you just use AI, because I have this experience like firsthand, you just use AI for a project and you keep adding more and more stuff. Eventually, all these errors are gonna be. They are gonna be, the kind of imperfections are gonna like expand on their own, and you're gonna have essentially at the end you're gonna have a bunch of layers of these, you know, the sections in the program which doesn't really work well together. And then you all of a sudden you ask the AI, hey, could you implement this? And then it's like, no, I can't do that. Okay, well, why? And it's like, well, I have to do this and this and this. Okay, well, start with the first one and then we'll go through it. And it's like, no, I can't do it. So it just gave up. And that was that. I had to like rewrite the whole project almost. So, and that's what I'm doing here, basically. So this project actually started out as a fully AI project. But when I actually went and looked at the code after a while, after having asked it to do, and it was like refusing to do the job, I went in to look at the code and I was like, hey, what the hell is this? It was like, it had made like several versions of the same thing, but in different places of the program. And then it was like, hey, I was like, hey, could you implement this? And it was like, no, I can't do it. Probably because it had like built all these different layers of, you know, branches of the program, which didn't really work well together. It was like working in some weird parallel thing. It's kind of hard to explain, but basically it made like several parsers and stuff. So it was like, I mean, I could have been better probably at directing it if I knew that this was going on, but I never gone in to look at the code. So you can imagine if, like, you know, I don't know, a CEO or, you know, someone who is not a developer who goes in and tries to build a project, a large project with AI, that's just not gonna work. It's not gonna work. All right. Not right now. It might work in the future. Right now, that's not how it is. You need at least people to kind of understand the code and see that AI is building something that can scale, basically. Okay, so let's say we have this rider. I'm just trying to figure out where we initialize it, because the initialize... Oh wait, but why is this an RC error? That's weird. This, well, no, that shouldn't be an RC error. What the hell? This takes an allocator. I guess we could just take an allocator, I guess. Yeah, there's nothing stopping us from just taking an allocator here. So let's just take the allocator and we will say writer is equal to init with allocator. Do we need to try this? Wait, is this the wrong thing? No, it's not. Oh, it's source. Right, source. And there we go. So now we have the allocating here. We have a reader interface that's gonna read from this allocating thing and like drain it along the way. Now, yeah. So yeah, so I guess the drain of this is like putting it into the thing. Like it's gonna it's gonna drain it into the allocated thing, I think. Yeah. All right, cool. Right, so what's gonna happen here? Well, we know that we have a source now, so we don't need to do this here. So self source. So now we have like written, but can we just, yeah, I guess we can take written and clear retaining capacity. We take it out. Actually, we could just do, no, because we have a limit as well, right? We have a limit and there's no limit thing in here that we can easily use. So we can basically say, let's take written and we'll take however many bytes we need from this. First in, first out. So this would be source, sure. Source next is gonna be limit slice. Okay. So now we should have that thing. And then we say source. We need to take from the start actually. I mean, yeah, that is the consume. Part. However, I think we need to dupe this slice. Yeah. Returning how many bytes are left. Well, I don't really care about that. We need to dupe this. All right. So now, and then we consume it. And we don't care about the results. Okay, cool. So we don't really flush, we consume instead. Cool. And then we, what do we do with that? We return it. Yeah. There we go. That's it, I think. Yeah, and okay. Deinitialize. We also deinitialize the source. Well, let's call this a writer actually. That makes more sense now. Cool. Okay. Now, back to here. Reader stream. So now this is the reader implementation here. The reader interface implementation. So the stream's job is to, whenever the reader's buffer has run out of stuff to send out to whatever needs to read it, it's going to call stream to request more things. So here, first, we're getting our stream here, and then we call this next inner, and now we can supply the limit here. So we supply the limit, and then we get our event out, and we can have, well, it's not going to be nullable anymore, so that's great. And we're rerouting some of the errors here, because this needs to be an IO reader's stream error. And then we say that, okay, well, if we got a completed event, that means we're end of stream. If we got a something else, that means we have some kind of payload here. And we actually just need to return how much was read, because I guess it's gonna get put into the buffer or something. Yeah. So this would be why don't I get anything here? Payload length. Yeah. And actually, yeah, we actually need to deinitialize this. It's kind of weird, like it's reading. Shouldn't we put things in the buffer? I think we have to put things in the buffer ourselves here. If we read this, returns number of bytes written. Oh, we're supposed to read stream to W. Oh, I'm stupid. Okay. Yeah. We need to use this one, and okay. Yeah. So we just do try write all payload, or wait, over here. So we write it, and then we return the length there. There we go, because that's supposed to be U8. We write it. We just write it there. So that was super easy. Okay, now I think the stream implementation is done. Yeah. And now we just do. Now we have to do these ones. But maybe these could be like, some of these might be able to be default implementations. We'll see. So discard is consume bytes from the internally tracked stream position without providing access to them. I see. So it's like it's gonna discard from the allocated writer probably. Returns number of bytes discarded, which may be minimum 0 and most limit. The number of bytes returned including 0 does not indicate end of stream. The reader's internal logic seek position moves forward in accordance with the number of bytes returned from this function. Implementations are encouraged to utilize mandatory minimum buffer sizes combined with short reads. Yes. The default implementation is based on calling stream, borrowing buffer to construct a temporary writer, and ignoring the written data. This function is only called when buffer is empty. Right. Yes, makes sense. So default discard is doing what? It is streaming into some kind of writer, which is discarding. Okay. I mean, yeah. We don't really, I mean, if you're gonna discard it anyway, why would we not do this? So let's just do default on that one. And what if, yeah, it's you don't even need to supply this function. So I'm just gonna remove that. Okay. Then we have readvec, which also has a default implementation, but let's just read so we understand what this is. Returns number of bytes written to data. Data must have non-zero length. Data 0 may have 0 length, in which case the implementation must write to the reader buffer. Okay. Data may not contain an alias to reader buffer. Data is mutable because the implementation may temporarily modify the fields in order to handle partial reads. Alright. Implementations must restore the original value before returning. Huh. Okay, yeah, makes sense. Implementations may ignore data writing directly to reader buffer, modifying seek and end accordingly. I just need to understand what this is doing. So basically it's like it tries to read from this data or something into the reader. Implementation may ignore data writing directly to buffer, modifying seek and end accordingly, and returning 0 from this function. Implementations are encouraged to take advantage of this if it simplifies the logic. Default implementation calls. So we just discard this data. Where's this data come from then? Okay, well, the default implementation calls stream with either data 0 or reader buffer, whichever is bigger. What? Okay, I still don't really understand what this is supposed to do. So you provide a data, but it might not be that one that gets read or writes to. Oh, it writes to buffer or data, whichever has larger capacity. Okay, whatever. Let's just use the. I really want to understand what's going on, but I think we will just use the built-in thing here as well. All right, rebase. So rebase is kind of I think what it does is like resetting the reader so it can use the buffer again or something like that. Ensures capacity data can be buffered without rebasing. Okay, asserts capacity is within buffer capacity or that the stream ends within capacity bytes. Let's just read what this is doing here. So we're grabbing the buffer. So this is like whatever data we currently have, I guess, in the buffer. And then we move the data into the start of the buffer, and okay, right, okay, I see now. And then we're kind of doing something with the capacitor. Okay, well, I'm just gonna do the default implementation. So stream is the only thing that you actually need to do anything with, because stream doesn't have a that doesn't have a default implementation, but the rest of them does. So good, great. All right, so that was actually a lot easier than I thought. I thought it was having to do all these weird functions, but turns out we only needed to do one. Cross my fingers. All right. So now we have this reader-writer stream. Let's see if we can put it to use. Okay, we're back to this mess here. Every time I go back here, my mind just melts. It's just, yeah. It's like energy draining.
Okay. Yeah, standard in reader. Well, that is gonna come from oh man, oh man. Okay, let's just let's actually do let's keep this in a list perhaps. So let's do like standard in list maybe, I don't know. So self allocator allocate. Let's do a couple of reader writer streams. So this would be stream reader writer stream. Oh my god. Of course. Public. Okay. So we're allocating pipeline status length of those. Maybe we just need -1, but whatever. Let's make these and yeah, I guess we could just set them up where we can just create them. So we'll just do like this, and we'll just allocate these. Are you even an error? No, you're not, so get out of here. Alright, cool. So now we got a bunch of reader writer streams. One for each pipeline stage. Now what? I'll just be 1 second here.
Let's see what we have here. Yes, okay. So the reader of this is gonna be standard in list index -1. Actually, you know what? This would be like if I is more than 1. If it's like, yeah, if we're not the first stage, we're gonna set the reader, because otherwise it's gonna be like blocking, like we're doing here. Actually, we could just set this directly here. We could just set, okay, wait, standard in. Actually, let's just do this. Type reader info. Well, we don't need to set it first here. Actually, let's set it to blocked default, but here we do like standard in equals init and then index -1. No, if index is more than 0. Yeah, if index is more than 0, then we take that and we take the reader interface there. There we go. Okay. So now each standard in the stage is gonna be set to the previous stage's standard in. Wait. No, this would be like standard out. Yeah, make this standard out actually. Oh, 1 second here. All right, we're back. Just gonna plug in headset on charging here. Let's see. There we go. I think, yeah. Okay. I mean, really, maybe this is like both standard out, standard. I'm just gonna call this reader writer list. Okay. Are we actually gonna make it now? Is this actually gonna be the thing? So, standard in. If index is more than a standard in is gonna be reading from the previous standard out, which is the reader here. Okay. And standard out, I mean, do we really need this to be like mutables here? Okay, whatever. Standard out, I guess else standard in is gonna be blocked, right? Standard out again. If it's the last, if I is 0, double equal, then standard out is gonna be inherit if we're not the last one. Standard out is gonna be init index. Wait, hang on. No, it's gonna be +1 writer dot writer streaming. Did we do it? I'm pretty sure this is correct. If we are not the first item, we will, or if we are the first item, we block standard in. Otherwise, we will take the previous stage standard out. And then for standard out, if we are the last item, we will inherit. Or if we are the, or otherwise, we will take standard in from, no, yes, we will write to the standard in of the next item. Okay, so now we have like, and then we push this context here. Now, I don't think we really need to keep these around. We can just delete these, make this a constant standard in, and I'm just gonna make these things here. Oops. Well, I guess we need to make them infos. I don't know. I don't think this expression is gonna look any better. However, I'm gonna do it. Like, yeah. Or we can, I mean, go back. We'll just put these in here. And we'll set them to undefined. We can also do, no, It's so annoying. Like there's no good way, I think, like formatting wise, to have. If you have longer like expressions, if you want to remove these and make this like a if expression type thing, it's always putting it on the same line. It feels like if we do this, or maybe it's not actually. Maybe we can do this. Pipe reader info equals this. How does that format work? Is it formatting now? Or what's happening? No? It's not formatting. Okay, well. Like there's no, it feels like there's like no good way of actually writing that. The what you would call the zig version of ternary. Okay. So we have all this crap, and we're pushing that. And after we're done, we will pop the frame. Okay. Yep. It does make sense. Okay, yeah, the first one is inherit. Yes, that makes sense. That's the rightmost one. That's the outermost context. And then we go deeper and deeper. Okay, yeah. And then we evaluate this expression. So basically what we've done is we've kind of... I mean, if we were only working with processes, we could do this in another way using like built-in pipes and stuff. But what we've done here is we've created our own kind of pipe thing system and generalized the concept into working with any kind of thing that can be a stream of strings or stream of bytes, and create a pipeline of that. Anything that goes on in here that outputs data is gonna be, or consumes data from standard in, is gonna be using whatever's happening, whatever is like the context that's set up here. Right? That's how this works. Okay, now I think we can just delete all this crap here. And we still need to think about what we should do here as well. So also like at the end, when we're at the end, once we've set everything up, we need to also look at, oh man, how actually is that gonna work? Like let's say you pipe the last thing into a function that will take like standard in. I guess it could work the same way as no, but yeah, but that's supposed to be blocking like now. Like we're supposed to wait for, I guess the functions themselves could be like asynchronous, and we just wait for the last one somehow. Like we could take the we could take the value returned maybe of the last thing and have some kind of general waiting thing for the last thing, like waiting for that to get like properly evaluated, or wait, we could just take the couldn't we just take like the last standard out or standard in and wait for that, or standard out? So then it shouldn't be inherited. We should actually create something that we can listen to, that we can wait on. until it's done. Okay. So let's do this. Let's get the standard out, which is gonna be scopes get standard out. Alright, so that's our standard out. Now what we do is we will say I think we want to have another reader writer stream, which is gonna be no, but that's the way. So actually this kind of implies that we're never gonna take the last reader writer. So the last reader writer is what we need to use for this one. Last is gonna be, oops, this one. This one is never used here because index is like goes from the end, but this one is like -1, so we never grab the last one. So we need to have, yeah, this is the one here. Okay, so you are the reader writer stream. It's not const. Why is it const? Why does it always do that? Okay, well, anyway. And then we will say what? Well, my idea was somehow that we would take this inherited standard out and we'll put something in between, which is supposed to be this thing here. But we can't really just set it. We have to like wait for it. I guess we have to consume it. I guess that's what we do. We have the standard out of the normal thing. So this is like the inherited standard out, or standard out inherited. And then we take the last thing that needs also to be connected now. If we are at the end, no. If we are the first item, standard out is not inherited. It's actually put into the last. It's put into the last thing. So this is gonna be last RB. It's gonna be the same thing. Actually, it's gonna be put into this. Yeah, so we don't even need this thing. There we go. But then this is wrong. Wait, no, that's doesn't work. No, this is gonna be the last one. Yeah, but that's the writer of the last one. So standard out of the last one should go to this standard out, but then we want this to be in between somehow. But that's gonna so that's gonna get standard in. Okay, standard in the last one, is that not even? That's blocked. No, I'm confusing myself. No, this is the standard in of the last one. Okay, I'm crossing my brain here again. No, so the reader writer, so basically the last item standard in is the previous writer, standard out is inherit. So I think we need something else in between, as I said like 100 times now, which is gonna be this one. So let's actually do like, this is not the last one, so actually we need to create one. Let's create one more of these. Okay. Do we need to like deinitialize this? Wait, you don't have a deinitialize. Yes, you do. Why wasn't that? Oh, I see. It didn't have a deinitialize of its own. We had to like do this deinitialize. Okay. Well, that same goes for these ones. Okay. Yeah. Now, you will be standard out is gonna write into the last thing. There we go. And the last thing is actually non-streaming. Which may make it not flush. We'll see. So, because we want to handle it ourselves. Well, actually, everything needs to be non-streaming in that case. Yeah, the streaming, non-streaming thing, I need to change that. It's really not helpful. Like, or described it really doesn't describe what's happening here, but not right now. Okay, so the last standard out, we will write to this last writer. Okay, yes, and then we can read it ourselves. So that's the last thing we'll read. So basically now we set up the whole chain. So it's like the last one will read from the whatever the process, the last process that puts things out. It's gonna put things in this writer, and we're gonna read from that. And then when we read, we're also gonna pull things through the whole chain. Basically, the whole chain is gonna. So the first process is gonna start pushing. It's gonna start like writing to the first reader writer, and then when we try to read from the last item, from the last reader writer, it's gonna start consuming, and then it's gonna pull. Yeah, it's gonna start reading from the previous writer, which will then start to read from the previous one and previous one until we get to the first one, and then it's gonna pull all the way through to the end. Or is that what's gonna happen? I guess we'll see. Also, in between, we have the processes. So the processes are in between as well. So the first standard out is reading from the first process as well. So the first process is going to put in the first standard out. The second process actually needs to read from the standard in. that is the issue though. Yeah, we need to. No, yeah. Yeah, okay. We actually need to loop through each process and forward everything ourselves, actually. So at the end here, now we've set everything up. Okay. We're gonna discard this value. We don't need this value here. And then we have to loop through. We have to do some kind of while true here. Yeah, because all the processes are gonna get connected here, so that's good as well. Yeah, now we need to basically, the first process is gonna push data that we then read from the reader. But it's not happening automatically. That's the thing. Like, this is all set up and everything, but it's not really gonna push for like data automatically. We have to call read and write into the next thing, I think. Like, we need to do this, whatever's happening in here. Alright, I feel like this is like the kind of the last thing we need to do in order to make this work here. However, this is very process oriented right here. So it feels like we kind of need some more generalization around reading from standard in and pushing it through this machine and then grabbing whatever comes out from standard out. No, because the standard out should be, that should work. We just need to read from the next one. Yeah, we need to go through each and read from their standard out. Oh my god, this is, man, this is, yeah. I need to take a break here. I'll be back tomorrow here. But yeah, this has been, there is so many turns and things. There's so much, I don't know. My brain just can't wrap itself around what's happening. I need to take a break and, well, we'll be back tomorrow. But yeah, thank you very much for watching.